Solaris is a huge part of Houdini that's getting better and expanding with each update. While Solaris is primarily built around the USD pipeline, we are going to explore more the practical side of it and less the technical side. In the first part, we are going to explore each key ingredient in Solaris in isolation, so we'll take a look at the stage manager, instances, lights, and other important components. And in the second half, we'll use all of this knowledge to build an entire magical forest shot from scratch. As a challenge, we are going to build all of the assets that we need directly in Houdini without using any third-party libraries. There's a lot to talk about, so let's get started and welcome to Intro to Solaris. It's impossible to talk about Solaris without mentioning USD. So Solaris is built as or at least started as a wrapper around USD. And USD is a lot of things at the same time, but mainly it's a file format. And in this sense, it can hold any type of 3D object. It can hold materials, lights, it can hold meshes, curves, and pretty much anything that you can find in a 3D scene. And the best way that I found this described is sort of like a Alembic on steroids. Now, USD is also a framework for how you build scenes. And really, if you go to the USD documentation from Pixar, you will find a lot of terminology and a lot of concepts, and it can be pretty overwhelming at first. Now, I just want to say right away that we don't have to know everything from the start. And as we explore Solaris, we will uncover more and more USD concepts as we go. Now, USD was developed as a studio workflow, allowing multiple artists to leverage all of their assets in one single scene in a very efficient manner. So it's more of a pipeline in that sense. And USD is here to stay, whether we like it or not. And more studios are adopting the USD workflows, and a lot of studios already have incorporated USD in their pipeline. So it is worth investing time learning it either way. But as a solo artist, if we are using Solaris, we can skip on a lot of USD terminology, and a lot of stuff is given to us for free. So we can do certain operations without really having to know the technical USD implications of those operations. So like I mentioned, we are going to slowly explore some of these concepts as we go. And here I am inside of Houdini. This is the geometry context. And to switch over to Solaris, we can hold down N inside this window over here. And we can, while holding N, select the LOPS tab over here. And this will take us to the stage context, and this is where we have Solaris. So whether I'm saying LOPS, stage, or Solaris, it's all pretty much the same thing. It's all just Solaris. And right away, if we are working in Solaris, it's worth changing our desktop here to one of the Solaris builds that Houdini provides. So we have Solaris and Solaris Look Dev. Let's switch over to Solaris, and now we have access to our scene graph. Here it says geometry spreadsheet, and this is because when we switch over, let's maybe just add an object in our stage context here. So we can drop down a simple cube, and now we can see we have our scene graph. And if we go over to the geometry context, so at the object level, we don't really have this cube. So right away, the stage and the object level are kind of separate universes, and you have to specifically tell if you want to import one object. So from the object level, if you want to bring it over in Solaris, you have to bring it in manually. We don't have our cube or any geometry existing in the same worlds at the same time without us telling it. So when we are at the object level, the geometry spreadsheet or the scene graph path becomes just a regular geometry spreadsheet. So if I add another cube over here or any geometry, this will just reflect our normal geometry spreadsheet with all of our attributes, and this is what we are used to when working in Houdini. So when we head over back to LOPS, this geometry spreadsheet now just becomes our scene graph. And this is a recent move from Side Effects. With every update, they're trying to make the communication between object level and LOPS level more seamless. So this is definitely a good recent change. Anyway, here in Solaris we have a cube and we can specify a primitive path, and most geometry creation nodes that we add will have some sort of primitive path that we can modify. So in this case, we can do something a little bit more specific, and let's maybe say that we are going to place this inside an environment group and inside maybe assets, and then we have our cube. So now our path has been updated, and we can see this over here. We have these nice little drop downs, and we can very easily keep things organized this way. Let's go ahead and say that if we wanted to bring more objects, I'll place this over to the side, and let's add a cylinder now. I'll place this over here, and let's give our cylinder a path as well, and we can place this inside the same groups. Let's do environment, assets, and here we'll type cylinder. Alright, and when we grab these both, I'll hold down Alt and drop down a merge node. When we look at our merge node, we can see that both of these are placed inside this environment and assets structure. So very easily we can keep things organized this way. In Solaris, you can also, if you want to combine objects, you can also just place them one after another. So we don't really have to merge them. We can do something like this, which is something that we can do in regular SOPs. And now if we look at this, we have the same thing with both of our objects combined. Now I still prefer using the merge method because this is something that I'm used to when working in SOPs, so it makes a little bit more sense to me. I usually prefer to build a chain like so maybe if I have another cube, I'll place this over here, do another merge, and I can more easily follow a main chain kind of logic working this way. But sometimes I'll just plug it in the actual existing chain without having to worry about this merge thing. Now when we place this, we can see that if we don't give our object a path, it will just show in sort of like our root folder. So this slash over here will be the first slash that we do for our path, will reference the stage environment itself. So any path that we choose must start with a slash. And $OS will grab the name of the node that we have over here. So we just have cube2. We can also place this inside the same structure. Here we can do environment, asset, and we can just keep the $OS. And we can see right away that I didn't spell this correctly. We have assets in the first version, so let's also change the path here to assets. And now it is placed in the correct location. And right away we can see that paths are super important when it comes to Solaris. And if you don't take care of your paths from the start, you will get extremely punished for this. And let me show you an example of a weird thing that might happen. Let's get rid of this cube over here, and I'll duplicate over my existing nodes with Alt and just dragging them over. So let's say that we have our cube over here and our cylinder, and instead of naming this cylinder over here as cylinder, let's go ahead and also use the name cube as well. So we have environment assets cube, and now it is the same path as our actual cube. So when we do our merge, we can see that just our cylinder shows, whereas here when we do our merge, we have both objects combined, which is what we would expect. And this is one of the USD concepts that was a little weird at the beginning to get used to. And what we are doing here with this merge, in this case, since both have the same path, we are actually layering an opinion. So in our main chain or our scene graph, if we bring in another object that has the same path as our previous object, the new object will override the previous object using this path attribute. So this is pretty important to know, because a lot of times if you have a cube, for example, and we have this path and we would like to duplicate this cube. So for example, if I were to just move this around and create a duplicate, move this around in space, and then merge these two cubes together, we would just get the result of our second input here on the left. And if I add another cube on the left here and I move this one around, we can see that our merge will only reflect the changes of our third input. Now, this might be super weird, but it's actually pretty helpful in the example where you might have a character and you want to swap out different animation for the character. So for example, I will bring in my character with a sublayer, and sublayering is one of the ways that we can bring in USD assets from outside. And over here, let's maybe make some room. I'll go ahead and load in my character base, which looks something like this. And maybe for now I'll just switch this over to dome light only. We can see we have a character in the rest state with no animation, and this is how our graph looks like. We have a body with all of our mesh objects, and we have some materials assigned to all of these mesh objects. Maybe make some room here as well. And now I have with another sub layer, I will bring in the animation. Let's bring this in, character walk. And this one I will have to offset the time here to -1000. So we have our animation. We can see hopefully our character moving. So this USD file has this animation, but it doesn't have any material assignments. And now if I were to merge my first sublayer with our base character, let's maybe rename this one to base care, and this one can be care walk. We can see if we look at our scene graph that both the base character and our character walk have the same path structure for the mesh objects. So now if I were to do a merge between my base character and the character walk, our mesh objects will get updated with the animation from the second input here, but it will also bring in all of the materials and the geometry assignments for those materials. So very easily we can see that in this sense let's say that our modeling department can work on the look dev of our character. So they will output a file with all of the mesh objects and all of the materials and the correct assignments and any attributes that we might need. And our animation department can only focus on animating the character without worrying about setting up the materials and all of that stuff. And when we merge these two assets together, we are going to get the final result with the character, with all of the attributes and the correct material assignments. And our mesh objects are now updated to reflect the current animation. And in this way we can also very easily swap out animation. So let's say that maybe we have something like a character attack, and if we have multiple scenes we can do maybe shot 05 character something, and we can just simply overlay that on top of our main base character that we get from modeling department. And we can also, we don't really have to merge these, we can also just layer them like so on top of each other, so to say, and we can see that everything works. So hopefully you can now understand that paths are super important when it comes to Solaris. We have to respect them, and I had to learn this the hard way because I'm a very disorganized artist and I like to just throw things randomly in my scene. I just want to get the scene up and running as fast as possible. But in Solaris, we do have to think a little bit about where we place most of the objects. If you are just prototyping a scene, you can maybe skip setting up all the paths right from the start. And maybe when your scene reaches a point where you have enough assets, you can come back and properly organize the structure. So let's see how a Solaris scene might look like. And again, this is if you are working as a solo artist. I'll go ahead and get rid of everything and start fresh. And one of the ways that we can create geometry is if we bring it over from the object level, or we can create it directly sort of inside Solaris. Let's take a look at the importing geometry part. Let's go over back to the object level, and let's say that we build some geometry over here. I'll drop down a geo container. Let's rename this. Maybe this will be our hero, and we are going to drop down the rubber toy. Let's drop down a match size and set the justify Y here to min, so it's on the ground. And we can also do a null, so we can point to this, and this can become our out hero. So we can grab this. I will select this node and copy this with Ctrl+C. Let's head back over to LOPS, and we can do a SOP import. And here in our SOP path, we can point to our, so this is the OBJ level, our hero geometry container, and our out hero, which points to our rubber toy, and we have this over here. We can specify a path here, and we can notice that this here says path prefix. So we can place this inside, let's say maybe assets, and we can have a subdirectory here. Let's do hero. So we have assets, hero, and then we have mesh 0. And in order to change the mesh here, we can add a name to our rubber toy. So we can go back into object mode. We can step inside here, and after our mesh size, let's drop down a name SOP. So this will just add a string attribute on the primitive called name, and we can specify the value here. We can do rubber toy. So now we also have a shop material path, which we will look into in a second, but now we have a name on all of our primitives. So when we head over in Solaris, we can see our mesh name updated over here to rubber toy. So the name attribute is recognized by Solaris, and also recognized by Solaris is going to be the path attribute, and the path attribute will override the name attribute. So to demonstrate this, we can use the same name SOP. Let's drop down another name SOP, and for this one we can see that the attribute here is name, so we can just change this to path, which will create this path attribute, again a string attribute on all of the primitives. And the name here, we can specify our own path directly, and for example we can place this, maybe let's choose another path than we did in Solaris. We can do something like model, or actually we have to start with slash, so let's remember that all of the paths need to start with this slash symbol here. So we can do maybe model, hero, assets, and we'll do rubber toy. When we do this, we can see our path updated here, and this is going to reflect in Solaris. So if we head over to Lops, we see now that even though we have this import path prefix here with assets hero, it's getting overridden by our new path that we have on the primitives, which is model, hero assets, and rubber toy. So let's go back over in geo context, and this is an important distinction, that the path attribute will override the name attribute. So let's go ahead and get rid of the path attribute for now and just keep our name attribute, which again will just assign a name for our mesh object. So now over in Lops, we can append or change any path prefix that we want over here, and our mesh will be the name that we specify at the SOP level. Now we can use the SOP import if we want to bring over objects from the object level, or we can use a SOP create. Let's drop this down, and if we dive inside the SOP create, we now have access to all of the geometry level nodes. So we can create our assets directly inside here, and this kind of functions exactly like a geometry container, only it brings the geometry up to the Solaris context. So inside this SOP create, we can again do our rubber toy, we can do a match size. Let's set this justify y here to min. And also when we are using the SOP create, it's always worth placing down an output, so this way we will know exactly which node we are bringing over into Solaris. So if we go up and I change the display to our SOP create, we have the same thing here, and we can specify, we can give this path prefix, we can use, let's do assets, hero, asset, and let's keep it as it is. And because we haven't set up a name, this will also be mesh 0. We can also see we have what's called here a geometry subset, and this is because SOP create will have some different options than our SOP import. Specifically, this is bringing in some attributes that concern the material assignment. So over in our SOP create, if we want to get rid of this, we can go to our options, import from SOP, and we should have in the import data here, we can see we have this partition attribute show material path. If we don't want to bring this in, we can just uncheck this, or if I want to keep this on, we can step inside here and we can just remove the shader that comes with the rubber toy. We can disable add shader here, and now if I go up, we can see that we don't have this anymore. So these are kind of doing the same thing, but SOP create I found that has a little bit more extra options, and for the most part I believe that Houdini wants us to work as much as possible at the stage level. So for our main scene assembly, we should stay in stage as much as possible and only bring the objects that we need in order to create more advanced simulations at the object level from the stage. So I'll go ahead and get rid of the SOP import for now and just focus on our SOP create. We can rename this. This can be our rubber toy. And now to add more elements here, we will need a ground. So we can throw down a grid for this. If we drop this, we can see that it's again going to be a SOP create, and if I step inside, it has this grid plane, and here in the geometry context, we can change the rows and columns. We can maybe increase the size here. Let's make this bigger. And again, it's always just worth to drop down an output whenever we are working with the subcreate nodes. Let's go up and let's also give this a path prefix here. We can place this maybe inside an environment group, and let's place this underground like so. And again, the default name here, mesh 0, we can change this if we give our grid a name. We can name this maybe, we can do grid. And now if I go up, we have our environment, ground and grid. So we can start to layer our objects together. We can again just place them below each other like so, and we can see we have our assets and our environment, and here it is. But like I mentioned earlier, I prefer using the merge method like so, and we have the same result, but this is just a little bit cleaner for me personally to work in this top-down manner. Because now, for example, if I were to have another maybe hero asset, let's do another sub create. Let's step inside and let's bring in maybe Tommy. We can also, I'll get rid of the textures and let's just do an output from here. We can also drop down a name, but it's not necessary to name all of the mesh primitives. More important will be the path prefix that we set. So let's go up and let's use the same prefix for our Tommy geometry. We can also rename this here. Let's maybe do not Tommy, but Tommy. And let's just grab the path prefix from our subcreate because we want to place this inside the same structure. So I'll grab the path, let's copy this and let's place this over here. Now the problem here, we can see in this case it's actually worth naming the primitive because we have mesh 0 for both our rubber toy and also Tommy. So again, if we do a merge, we are going to override the rubber toy geometry with Tommy. So if I do this, we can see they're not combined. Tommy is replacing the rubber toy. So a better way to do this is to maybe be a little bit more specific with our path prefix. We can do here assets, hero assets, we can do rubber toy, and now we can see our objects have different paths, so the merging works as expected. And here we can also do hero assets slash Tommy. And let's take a look at our scene graph now. We have our hero assets, we have the rubber toy and Tommy, and both of these have this mesh 0 again. You can assign a name attribute to these if you want, or you can just be more specific with your paths. And here is why I prefer working with this merge kind of top-down structure, because I can organize the elements vertically, but I can also spread them out horizontally. So if I have multiple hero assets, I can just merge them here horizontally, and then we can keep things a little bit more organized in this way. Let's go ahead and get rid of this. So maybe I can also grab all of these assets. I will do Shift O to draw a network box, and I can name this maybe hero assets or hero characters. I can drag this over to the side, and here where we have our grid, this can be our environment. We might add some more elements later as we populate the scene, but let's leave it as it is for now. We are going to need some materials, but we are going to take a look at that in later lessons, and we are going to need some lights as well. So we can drop down a Karma physical sky. Let's go ahead and merge this in like so, and we can see our graph. This is going to be placed inside a lights group, and we can determine the primitive path over here. I'm just going to leave this as it is for now. And very quickly we are starting to build a scene, and now that we have our lights, we can also start to do some test render. So if I press Shift R over the viewport, we can get our rendered view, and here we can see we have this very annoying outline of our objects. Let's disable this if we uncheck this icon over here, and now we can see that this is set to Karma XPU. We can also change this to Karma CPU, so we'll talk a little bit more about these in later lessons. Let's leave this as Karma XPU for now, and let's go to our light here and maybe just increase the exposure Let's try maybe 2. We can also soften up this shadow if we increase the angular size. And we'll explore the lights a little bit more later as well. Let's maybe for now just drop down the altitude, and maybe I can change the azimuth here, which is the angle of our sun, to something a little bit more dramatic. So very easily we can build a scene and start to render things. Again, here with this structure, if we wanted to add more lights, we can drop down, let's drop down a light, and I can just merge them over here, keep things organized. We can see in our chain, this will be automatically placed inside our lights group, and I'll drop this down. And again, here we can drop down another network box with Shift O, bring them over to the side, and I can keep layering and adding more lights horizontally. So let's maybe just leave the one light here. I'll press enter and I can grab this, move this over, just so we can also see it in the viewport, and maybe I'll make this another color. So now if we do a test render, we have an extra light. We can also disable the light icons in the viewport if we uncheck this option to display light guides, and maybe I can just increase the exposure here a little bit as well. So we have our lights, and finally we are going to need a camera. Now for the camera, I don't really like to place this horizontally because I'm not ever really stacking cameras horizontally, so I can just place this directly here in the vertical chain. I'll drop down a camera and we can rename this. Maybe we are working on the first shot. This will be shot 01_cam, and I can select the camera view from over here. Now we can go to our options here, and I will lock the camera view and pull this back so we can see our objects, and we can adjust the camera view like so with our locked icon here. In the view tab we also have most of our normal settings that we are used to from the SOP level, so we can increase or rather decrease the focal length. Maybe I can widen up this camera a little bit, and we do have a lot of options for the camera. We can also add camera lens effects in Solaris, so a lot of cool stuff, and maybe we'll take a look more into cameras in later lessons as well. But now we have our camera, and the final component to finish up this very simple scene would be to add a Karma render settings node. So here is where we can choose our engine. Let's set this to XPU. We can increase the path trace samples to increase the overall quality, and we have a lot of options that we can play with here. We have our depth of field, motion blur, limits, and we are going to slowly explore all of these options as we go. So with this final node here, if we want to export out a sequence or an image, we can drop down a USD render ROP, and here we can decide if we want to export a single frame or a specific frame range. We can choose the delegate here, which should be the same option as our Karma render settings. So here, if we are using XPU, this should be set to Karma XPU as well. And there are a few more options that we are going to explore here as well. But this is how a simple scene might look like with just a few elements. We usually have an environment, we have some hero assets on top, then we bring in our lights, our camera, our render settings, and then we can save this out. Now about the Karma render settings node, if we don't have this node added to our chain, we can see that currently the display is to our Karma render settings node. But for example, if we don't have this, if I'm going to preview the scene before we add our Karma render settings node, so from over here, from our camera, we are going to use different render settings, specifically the viewport render settings. And to change these settings, we have to press D while being over the viewport, and here are the settings that the viewport is actually using. So if I want to increase the quality, I can increase the path traced samples over here. I can change this to Karma CPU if I want. And something that might happen if we go through the camera, you might see that maybe the objects are a little bit blurry, and this is because the depth of field is turned on by default, and in the viewport settings here we can choose disable depth of field if we don't want to preview this. So it's it's just important to note that the display options are going to be used when you don't have a render settings node. And if you have this active, then whatever we are seeing here when we do our render, we are going to use the options that we set over here. So it's a pretty important distinction to make right as you start. Also, as a quick note, you should, whenever you add a Karma render settings node, the first thing that you should do is change the camera path to reflect the actual camera that you're using. By default, this is going to use this cameras and camera 1 path, which currently we don't actually have in our scene because we renamed our camera to shot 01 cam. So right away, whenever you add this, you should just build a sort of reflex to right away change the camera path to reflect the actual camera that you have in your scene. So let's say that we have our simple scene here, and naturally a big part of scene assembly is going to be moving things around. So let's see how we can do that. If I have this last Karma render settings node selected, I can press S in the viewport and I can grab an object. Now it's better if we show the object outline by turning on the display selection button over here. And now if we press S and select an object, we are going to see the outline. And if I press T, we can see we have the transform gizmo and we can move the objects around. And we also have appended automatically an edit node right after our Karma render settings. So I can now grab the rubber toy and I can move it around. I can rotate this. I can press E for scale, R for rotate, and T for translation. I can also select the assets directly from our scene graph. So if I select Tommy from the scene graph, now I can move Tommy around and I can of course scale and rotate and do all of the usual transform operations. And we can see that all of these are stored in this edit node that was added. And for example, the coolest part about working in Solaris is that we can treat almost everything as sort of like an additive operation, meaning that if I were to disable this node, I can now preview our changes, I can turn them on and off, and in this way I can sort of stack a lot of operations on top of each other, and at any point I can disable and enable them as we see fit. So this is really cool, but this edit business here is not really ideal. It's not really my preferred way of working. So for example, if I were to delete this, let's maybe say I have another node selected, I have our rubber toy selected. Let's maybe say that in our chain I have this merge over here selected with just our grid and our hero assets. So if I press S and grab our rubber toy and press T, now our edit will be appended over here, but sometimes this edit node gets placed randomly in the scene. Usually it should be appended after the last node that you have active. So if we have the merge, the edit is going to be placed after the merge, but sometimes it's just being placed randomly at the end of the chain or some other place. So it's kind of weird working like this. It's not really ideal, but you do have this option with the edit. You can also just simply use a transform like you would at the sub level. So after the merge here for the hero assets, if I were to drop down a transform, we can move things around by using the handle now, and this will automatically grab all of the objects that's above the transform. So in most cases you will have to specify which object you want to transform, meaning that I can select only to affect our rubber toy. I can grab and drag this in the primitive path over here, and now our transform will only grab our rubber toy, and we can stack again. We can disable or enable this. We can do another transform, and I can set this to work on Tommy. And now I can move Tommy around, but again, we are stacking operations, so this is fine, but this isn't really the most ideal way. You can imagine that if we have even as few as maybe 5 or 6 objects, this transform operation business can get a little bit annoying. So a better way to move things around is going to be by using the stage manager. We can again place the stage manager wherever we want in our chain, as long as above it we have the objects that we want to move. So in this case, let's say that maybe I just want to operate over the hero assets. I'll do a stage manager after our merge, and now in our stage manager we have our properties over here. We have a scene graph which contains all of the objects that we have above it. So we have our assets, our hero assets, and we can again select them from over here, or now in our viewport with the stage manager active, I can grab and transform the the objects. I can hold down S, select the rubber toy, release S, and then grab the transform and move it around, scale this, and perform any type of transform operation. So maybe I'll move this around over here. And again, we can see our controls on the left over here. We can hold down S, select Tommy, release S, and then we can transform him, move him around. It's going to take a little bit of getting used to, so hold down S, select your object, release S, and then you can transform the objects. We can also now duplicate our object. So with this rubber toy selected, I can press D, and this will create a duplicate. We can see here we have populated the scene with rubber toy 2. I can move this around, drag this over, rotate this, scale this down. Let's maybe scale this horizontally. I can do another copy, so Control D. Let's grab this one, place this around, transform this. And now if I want, I can grab all of these rubber toys and place them inside a group. So again, I will hold down S, hold down Shift, select the other rubber toys like so. Then we can release S and Shift, and now we have selected all of them, so we can move them at the same time. And with all of them selected, I can press Ctrl G to place them inside a group. We can see that we form this group 1 over here. And if I want, I can rename this group. So maybe I can do hero underscore assets. And it's important that you use underscores here whenever you are naming any group, or for that matter, any object inside the scene graph here. So I can always now grab this group, move all of them over, I can scale them down at the same time, and I can copy this entire group with Ctrl D, I can duplicate, and I can move over this new group, scale it. If I want, I can press Insert to move the pivot of the transform, and then if I press Insert again, I can grab this, move it from the new location of the pivot, and we can very easily populate our scene and move everything around. So really my preferred method, at least when it comes to manually placing objects, will be with the stage manager. It's really cool, especially now in the latest versions. In the first versions, this was a little bit of a pain to work with, honestly, but now it's really usable, it's pretty pleasant, and it's super powerful in the sense that, again, this can be treated as a additive operation. So if I want, at any time, I can just grab this, press Q to disable the node, and now we have undone all of our operations, and I can always enable this back again. And for example, now what we can do is we can have very easily multiple versions of our layout with just this stage manager. I can, for example, layer a new stage manager on top of this one. So if I want, I can drag down another stage manager below our first one. And with this second stage manager, I can maybe make some further changes here. So I can grab Tommy, move him around, and I can maybe grab some of these groups and do some new positions like so. And I can always just disable these changes. We can very easily make a lot of variations for the layout. And hopefully you are starting to see the flexibility of using the Solaris workflow, where at any point you can layer a lot of these changes throughout your chain. So I can even place a stage manager wherever we want, really. And if I go to this one, I can again grab the assets, I can move them around, I can grab the environment which has the ground. So really cool way to work with the stage manager. It just takes a little bit of getting used to be honest. And one thing about the stage manager, if you are experiencing a rather slow performance in your viewport while you are moving things around, this might be because you are previewing the stage manager edits from a node that's on the end of the chain. So for example, if I were to preview the Karma render settings node, I can go all the way over to the stage manager again, and let's make sure that this is active. And now as I move things around, in this case, since we don't have a lot of objects, we can see that for the most part it's pretty responsive. But if we were working on a larger scene, whenever we are doing any change in the stage manager, this will have to recook or process all of the nodes until the node that we are actually previewing. So if here I am previewing the results from the Karma render settings node, every time I do a change in the stage manager, it will have to run through this merge and then this merge with the lights, with our camera, and finally with the Karma render settings as well. So if you can, try to preview the changes of the stage manager directly from the stage manager itself, or maybe another extra node down the line. Or for example, if I do want to preview the results from the Karma render settings node, I can just grab some of these other nodes and I can disable them with Q, And now if I go back to the stage manager, we should have a better performance in our viewport because we don't have to process these nodes every time we do a change. So this is just something to keep in mind, and also make sure that whenever you want to use the stage manager, you have the stage manager active, meaning that you have this information tab over here. So for example, I can have the stage manager selected, but if I press escape, now it's no longer active. And if we want to move things around, if I press S and grab this rubber toy and move it around, we can see that this will append an edit node for us. So it's not going to do the changes in the stage manager. So we have to always make sure that the stage manager is active. We can select the stage manager, and now it's currently active by default, but for example, if it weren't, so by pressing escape, I get out of the stage manager view, and to get back into it, I have to press enter. So just always make sure that you have the stage manager active whenever you want to make any of these changes. When it comes to assigning materials to our objects, there are quite a few ways that we have available, and let's explore some of these. So the first method, and my preferred method of assigning materials, is if we drop down a material library. Now again, we can place this wherever we want in our chain. It just has to be after we place the objects in the scenes. So with this material library, in order to create a material, we have to double click to step inside, and inside here we can drop down our material builder. So if you have Redshift or Arnold, you can drop down a Redshift material builder or Arnold material builder, but since we are going to use Karma, we are going to use a Karma material builder. So let's go ahead and drop this here. We can also rename this. Let's maybe name this green. We can step inside, and this is going to be a Material X shader, and we'll explore some of the things that we can do with this material builder in a later lesson. But for now, let's go ahead and just change the base color. So let's go ahead and let's make this green, and we can go up by pressing U. Let's go up one more time until we are at the Solaris level. And now if we look at our scene graph, we have our assets, and we also have a new directory here with materials, and inside it we have this green material that we created. And we can of course change where we place these materials. So for example, if I want to place them inside the assets directory here, I can just do /assets, and now our material group will be placed inside our assets as well. So always worth keeping things organized in Solaris. And now we have quite a few options over here. We have to specify which materials we want to bring in our Solaris scene. So for example, let's go ahead, let's go back inside. Let's duplicate this material by holding Alt. I'll name this one red, and I'll step inside and change the color here to red. So let's say that we have another material now that's called red, and we can see this here. Now we have to specify which material we want to bring in. So for example, inside this material VOP option here, currently this is set to the star symbol, which is going to bring all of the materials that we have. But for example, let's say that we only want to bring in our red material. So I'll go ahead here and select our red material, and now our scene graph has been updated with only our red material. And if we want here inside the material path, we can also override whatever prefix we have set over here. So if we do another path here, let's do maybe mats, and we can do /hero mats, maybe we can see that we no longer have this namespace that we used over here, but instead we have just our mats with our hero mats inside. So here again, we can just override whatever path prefix we have at the top. And now we can also assign this to our geometry directly with this material builder. Let's click assign to geometry, and we can either drag our objects inside this path. So let's maybe assign this to Tommy. I can just drag it over here, and now we can see our material in our scene. And we can also use this cursor icon over here to select our objects. So for example, if I remove this assignment, I can click on this arrow, and now I can select a different object on which we can assign it. So we also have this option as well. And now inside here we also have this green material. So let's go up and let's click on this plus icon and bring in a new material, and this will be our green. I can just type it over here. We should see it in our scene graph, and maybe I can assign this one to Tommy. So I will just drag this over here, and now we have both of our materials. Now if for example we had multiple materials, let's maybe create a few more. So let's maybe do one orange, and we can do one blue, and let's maybe do one more, which will be, let's do maybe purple. And I'll go ahead and change the color real quick for all of these. So let's do here blue, and let's do also purple as well. All right, so now we have 5 materials. Now we don't really need to, let's hit clear first, and we don't really need to assign all of the materials ourselves. Let's hit clear one more time, and we can choose this autofill materials option, and now this will bring each material with its individual sort of tab over here. The problem with this autofill materials is that by default it's going to assign this material path as well, so we can see that all of our materials are placed over here. So again, it's going to override whatever materials path prefix we have set here. So it's a little bit annoying that it does this by default, but we can go ahead and change this if we want. We can just place this inside the assets directory if we want for each of these materials, but let's just leave this as it is. So now again, I can just grab whatever geometry we want for each of these. Let's go ahead and assign this one here, and we can choose one more maybe for our orange, and hopefully you get the idea. Now, when we have a lot of different materials, we can also use a material linker node. So let's drop down this material linker, and let's go ahead back in our material library. I'll hit clear here and autofill materials just to bring our materials, and in our material linker we'll have all of our materials on the left, and we will have all of our geometry on the right. So if I want, I can drag the blue material here, and I can assign it to whatever geometry we want from the right. So we can choose, let's maybe assign this to all of our hero asset group here. I will hold down shift to grab all of these, and I can assign them like so. And then I can grab the orange one, and I can assign this one maybe to Tommy. And for example, for the blue one, let's say that I want to exclude from this list one of these rubber toy geometries. I can grab the one that I want to exclude, and I can just drag this over to the exclusion list. So now the material will be removed from this selection. So the material linker is very useful when you have a lot of geometry and a lot of materials that you want to assign quickly. We also have recently added, there's been a catalog here which contains quite a few more basic materials that are ready to use. So we can import either of these materials. We can bring in the asphalt maybe, or the car paint. So these are preset materials, again based on material X, which we can use. And there's also, if we go to the cogwheel, there is also more recently added this AMD Material X library, which we can use. So in order to use this, we first have to download it. We can just choose our destination here, and I can just give this name, or rather file, a name. And now we can see that slowly we are going to download a lot of these very cool materials. Let's maybe expand this window here. So there's all of these preset shaders for Material X that we can use, and we can bring any of these in our material list over here. So maybe I can bring in the granite, and we can see that this is going to take a minute to download all of the necessary assets. But now that we have our granite, I can just bring this over here, and maybe I can assign it to some of our other hero assets. Let's place this here, and now we can see here we have our granite texture. So the material linker is very useful when you want to do a lot of assignments at the same time. And I'll go ahead and delete the material linker for now. We also have a assign material option. So if we do a assign material, this will just do what it says. This is only used for assigning materials. So for example, I can drag the blue material in the material path, and I can assign this maybe to our Tommy geometry, and we can see this here. But the cool thing about the assign material is that we have more options on how our materials are assigned. So for example, in the material binding, we can specify the strength here, and without going too much into detail, because this can get a little bit confusing, let's say that if your object comes with a material assignment, we can override that assignment with this with some of the options over here. There's also some other cool things that we can do. If we set the type here from explicit path, we can either use cvex script or vexpression, and here we can type some vex code in which we can create automatic material assignments for maybe multiple objects at the same time. So this assign material is really useful in some of the cases. And finally, also recently added, there's been we can do do a quick surface material, and this just creates a material X for us without having to create a material library and then diving inside, setting up a material builder and all of that stuff. We can create a very simple shader by having all of those options already exposed for us. So for example, if I set this to green, I can maybe give this a file path here. Let's do materials, light, green. So now we can see this material over here, and to assign this to our geometry, we do need to use a assign material, and here we can specify, we can drag our light green and we can assign this to our geometry. So I'll drag Tommy and we can see this here. And I believe this is mainly used for prototyping. So if you want to quickly just add some assets to your scene and assign some basic materials to them, you can use the quick surface material. But to get the most control and create custom shaders and more advanced materials, then you'll have to use the material library. So these are a few ways in which we can create and assign materials. And again, we'll take a deeper look into material X in later lessons. So we can definitely create geometry with the SOP create and the SOP import nodes, but a better way to author assets is going to be by using the component builder. So if we were to drop down a component builder, we can see that if I place down this node, this will automatically build for us this entire chain. So very simply put, we have our component output over here, and we can now see our current scene graph indicates that we have this component output, and it has a scope for the geo and the MTL, which is going to be the geometry and the material. And if I rename this here, let's say that we are working on our hero asset, I'll just name this hero. This will now update in our scene graph over here. And we have our component geometry where we add the actual mesh geometry over here on the left. And we can create our material inside this material builder here on the right. And with this component material node, this will automatically apply the material to our meshes. So let's take a look at a quick example. If I go to the component geometry node, we have a few settings here. And if we wanted, we can create the geometry directly inside the component geometry. And this is what we'll do in a second. But we can also specify an external SOP network, for example, so we can reference a geometry from the SOP level. We can also bring in files, but let's for now keep this as the first setting. And if we dive inside, we will have three outputs over here, which is going to be for the render geometry, the proxy geometry, and the sim proxy. And we'll go through all of them in a second, but let's first say that we will bring in our Tommy geometry. And let's go ahead and also remove the textures as well to keep things simple. We are going to place this in our first output, and if we go up, we will now see in our component output, we have our geo directory here, which contains this shape mesh, which will be our Tommy geometry. And now in our material library, I can step inside and I can create, let's drop down a Karma material builder. And again, we'll just keep things simple and let's just name this one green. I'll step inside and I will change the color here to green. And we can see automatically when we do this, let's go up, we can see that this is automatically assigned to our geometry, and this is again through this component material. And by default, we can see that it's going to grab all of the primitives on the left and it's going to assign all of the materials on the right, so over here. Now let's go back in our component geometry, and if we want, we can also provide a proxy geometry. Now usually the proxy geometry is just a poly-reduced version of our render geometry. So let's go ahead and drag this over. I'll place down a null and let's say that this will be my geo. From here, we can drop down a poly reduce and let's maybe use 10% of geometry to keep, so we can see with and without our poly reduce, we get this. And then we can plug this as our output, and our component output node here will now contain this proxy subdirectory inside our geo directory over here. And we can now also see this reflected in our viewport. So by default in our viewport, we will be previewing this proxy geometry, and when we do our render, we are actually going to render the high quality mesh. We can also change these if we wanted to directly here. So if we click on the sunglasses icon here, we can see that it selected the proxy. And if we wanted to, we can preview the render geometry at the same time in the viewport. And now, for example, I can turn off the proxy geometry and we can just preview our high quality mesh. And like I said, this switch happens automatically when you activate rendering in the viewport. So as long as we have some proxy geometry inside this component geometry node, we are good to go. It will be handled automatically for us. Finally, we also have a seam proxy here, and usually for this you can again base this on your high quality geometry. We can from here do a shrink wrap, and this will create this is sort of like a convex decomposition, and this is just to create a simple mesh representation that can be used for collisions. Let's also clean this up a bit by using a remesh, and maybe I can increase the divisions here. Something like this will be fine in our case. And here for both the proxy and the seam proxy, you can be a little bit more detailed. You can also use for collisions maybe another version of the polyreduce, but generally you would be using something like a shrink wrap or, like I said, a convex decomposition node. So this will be fine, and again in our component output we will have updated our path over here. We can see we have this seam proxy subdirectory as well. So if your asset has this seam proxy, now for example, if I were to drop this inside a stage manager, I can grab my hero asset, I'll move this around, I will press Ctrl D to duplicate. Now I can turn on use physics. We see we have this option over here. Let's add physics to our object, and I will also press S, select this other object, our first one, and click add physics as well. And now our objects can basically interact with each other using their seam proxy geometry. So if I drag this over, we can see that our character will avoid our duplicated character. No matter what I want to do now, it's always going to collide with our other character. And again, this will be using our seam proxies. So I can also turn on display seam proxies. And this is actually we can see that this is what's happening. So this is a pretty cool and useful feature if you want to do some sort of assembly where you might have a bookshelf and you want to place a lot of books at the same time and you don't want them to intersect with one another. So for example, if I were to, let's turn off display seam proxy, let's create one more duplicate. So I press Ctrl D. For some reason we still have to click this add physics button even though it was already turned on, and let's do Ctrl D one more time, and again I'll click add physics, drag this over here, hold down S, shift, select all of these, release S, and now I can, if I scale these while having the physics option selected, we can see that this is kind of what's happening. So it's a really cool way to stack objects, and it's a pretty useful feature. I honestly don't find myself using it that often, but it's there, and this is just to, let's go ahead and get rid of the stage manager. This is just to demonstrate what this seam proxy geometry is referring to. Now let's go up, and we have a few more options here for our component builder. Mainly we can also create variants for both our geometry and also our materials. So for example, if I want to add a variant for the geometry, we can, let's go ahead and rename this one to Hero Tommy, and I'll go ahead and duplicate this, and this one I can rename to Hero Toy, and let's step inside, and instead of using the Tommy geometry, let's replace this with our test geometry rubber toy. I'll place this over here, and we can see our default mesh will be the one that we are using as our render mesh. Then we have our polyreduce mesh for when we display this geometry in the viewport, and finally we also have our seam proxy mesh. So let's go up, and in order to turn this into a geometry variant of our hero asset, we can throw down after our component geometry node, we will do a component geometry variants. Let's go ahead and drop this here, and let's plug our second component geometry inside this node. And now our mesh is replaced by our rubber toy. Let's go ahead and also disable the outline here. So now what I can do from here is after our component output, and by the way, here we can save out our file to disk, and most of these settings, especially if you're getting started, the default settings here for all of this should be fine. So you can probably leave them as they are. And for example, now I can save this to disk, and everything that we did so far is now packed inside a USD asset. So if we grab this location, I'm just going to copy this path. We can drop down a reference node and we can go to our file pattern, and I'll just load in this file that we saved. And now we can see we have our hero asset with all of the geometry that we needed, with all of the material assignments, and I can now plug this wherever I want in my chain. For example, I can plug this in our scene example, and we can see this here, and we can also see this in our graph. So this is more or less what the component builder will do for us. Now, if we go back to our component output from here, because we added this geometry variant, we can go ahead and we can use a set variant node, and here we can choose the variant set, so we can have multiple different sets that contain different variants. So that's really cool. And by default, the component builder will give us this geo variant set, and here for the variant name I can choose between our Tommy or our toy variant. So I can choose Tommy here, and we can see here it is, or I can go back to toy, and we can add as many variants as we want. So for example, I can do another duplicate of this. Let's go ahead and rename this one to, let's do maybe hero cube, and instead of this rubber toy, let's just drop down a cube, place this over here, go up, and I'll add this to our component geometry variants. And inside this set variant, now we should see our hero cube, which because of the polyreduce node, it turned the cube into like a pyramid. So this is for the geometry variants, but we can also add material variants. So in our material library, let's say that we want to add some different kind of materials that we can choose from, and I'll go ahead and duplicate the green subnetwork. I'll rename this one to red. Let's go inside and let's make the color red. Let's go up, and in order to add this new material as a material variant, we will have to duplicate our component material node. So let's go ahead and hold down Alt while dragging this. I'll go ahead and remove the connection because we just have to plug this directly in our chain. And now we will actually have to specify which material we want to assign to our geometry. So again, the primitives we will leave as it is because we want to assign a material on all of the primitives. But for the material path here, I will go ahead and choose our MTL. Let's navigate and let's choose our red material. And I can also now rename this one to red. And it's pretty important to rename your node because this is the variant name that we will give for our material variations. And now for our first component material, let's go ahead and assign our green one in our material path, and I will rename this one to green. So now after our set variant, let's go ahead and use another one to select our material. Let's go inside, and in our variant set here, let's go ahead and choose MTL, which is the set that holds all of our material variations, and I can choose now our green material or our red material. So pretty powerful stuff, and again, all of this is going to be saved in one single USD asset that, so if I save to disk, I can go ahead now and bring this as a reference. Let's go ahead and point to our file over here, replace the file pattern, and now I can bring this in, and all of the variant operations that we did with our set variant for the geo and our material will work. So I can go back to the set variant and I can choose our hero. Let's do hero Tommy. I can either assign the green material or the red material for this. So really cool stuff. And now, for example, with this single USD file, I can populate an entire scene if I wanted to. Now, in order for this to work, we have to bring this in as a payload file. So now if I plug this reference node inside a stage manager, we can hold down S to select our asset. I can move this around, and now I can press Ctrl D to duplicate this. And if I want now, I can right click on the asset. So make sure that you're not right clicking inside the transform gizmo. Let's go ahead and right click. We can go to Geo and we can choose some of our other variants, we can select our hero Tommy variant. We can also right click to select a different material variant. So I can make this one green. I can do Ctrl D, make a new one, select another geo variant. Let's bring in our toy. We can also now make this red as well. And very easily you can see that if we just had a few variants on just one single file, we can very easily populate an entire scene this way. So again, I just need to right click here, select our geometry, and let's go ahead and press enter. So we'll bring back our gizmo and I can maybe scale this down a little bit. So hopefully this gives you an idea on how the component builder can be used to make really advanced USD assets that contain a lot of information and the geometry variants and material variants. So it's a pretty powerful workflow, and we'll explore more on some of the stuff that you can do with this component builder in later lessons as well. When it comes to lights, Solaris offers us plenty of options when it comes to lighting our shots, and let's explore some of the lights that we have available. In earlier lessons, we looked at the Karma Physical Sky. So this one has basically it's made out of two components, which is the sun and the sky. So the sky in this sense is going to act like a sort of HDRI, and the sun will be more of a directional light, and we can control both the sun and the sky tab over here. And I really like the Karma Physical Sky because it's a pretty fast light, and it's just something that you can plug down in your scene and you can get started with some really simple lighting. And really for outdoor scenes especially, this works surprisingly well. So we can play around with the solar altitude, which will bring our sun down, and we can see we have sort of like the sunset look. With the solar azimuth, we can spin the sun around so we can change the angle of our sun. And finally, we also have the angular size over here. Let's maybe bring the sun down even more so we can see it. As we increase or decrease the angular size, this will make our sunlight smaller, and when our light is smaller, our shadows will naturally be sharper. And this will be the same for any type of light that we add. The smaller it is, the sharper we will have our shadows, and the larger it is, we can see that our shadows start to soften up. And then we can control the intensity and the exposure. And then in the sky tab, we also have a few options that we can play around here. We can maybe change the overall color. We can give this a different tint. So if I make this purple, we can see our updates over here, and we can choose to not render the light geometry if we want. And now we only see our sky. So the physical sky is really cool, and more recently they added the atmospheric type. So if I set this to atmospheric, we will have a lot more options, and right away we can see that we get a little bit of this volumetric scattering, and this might take a second for it to load properly in our scene, but once it's loaded, it's pretty fast. And now we can see that straight off the bat we get an overall nicer results, and we have more of a gradient effect, especially with this sunset kind of angle on our sun. Maybe I can increase the exposure. But now basically our physical sky is going to be made out of this sun, and now instead of the sky we have the atmosphere tab. And here we have a lot of options for how our light scattering is being calculated, so we can play around with some of these options and we can get some really interesting moods. You can experiment and choose different colors here and see the different kind of results that you get, and you can see these kind of crazy gradients that we can start to create. So there are quite a few options over here which I really encourage you to go in and experiment and see what each of these do. So this will be the Karma Physical Sky, and overall it's just a really cool option to just drop down and light up our scene and do some look dev and maybe get some initial light going on. But naturally we would want to bring in our own HDRI, so in this case I'm going to get rid of the physical sky and I will drop down a dome light, and in here we will bring in our HDRI. So in the texture slot I'm just going to load one of my HDRIs and I'm going to plug this in our merge. We can already start to see this in our viewport, and if we do our render now, this will take a second for the textures to convert, but once that's done we can see this here and I can increase the exposure. And also now in the transform we can go ahead and with the second value of the rotate I can even rotate rotate the HDRI around and choose a different angle. And if I close the render and go back to the viewport display, in order to hide the light, maybe we don't want to see this, we will press D to go to our display options, and in the background tab over here we will see this option. We can uncheck display environment lights as backgrounds, and now this will hide our image in the viewport. And also when we do our render, this will hide it in the render as well. So this is how we can disable it through this option over here. Let's leave this disabled for now. So this will be our dome light. Pretty simple, pretty basic. Let's go ahead and maybe just drop down a simple light. So if we just drop down a light, this will be our basic point light. So if we drop this here and plug this in our chain, let's do a render, and I'll go ahead and let's press enter so we can bring this up, and we can increase the exposure here so we have more contribution overall. Let's maybe bring this in front of our Tommy character, and we can do something like this. So let's maybe increase the exposure even more, and we can straight away see our very sharp shadows here. And this is because by default this point light will be a point that's infinitely small, which will give us the sharpest shadows that we can possibly have, basically. So if I wanted softer shadows, I can set this to a sphere, and now we can see instantly that it's going to use this entire geometry over here as our light, and we can see that now our shadows are a lot softer. And if I wanted to, I can scale this down. So if I grab the scaling handle over here and start to scale this down, we can also see that it's going to lose the intensity, and this is because by default our intensity is also directly related to the size of our light, and we can choose here to normalize power if we want. And now no matter how big or small we make our lights, it's going to have the same intensity. Now for example, if I increase the exposure, we will keep this, let's maybe just give this an exposure value of 5. And now if we look at our shadows, as I start to decrease this sphere, we can start to see our shadows getting sharper and sharper. And again, this is just to illustrate that the shadow sharpness is tied to the scale of our lights. We also have here, if we set this to a rectangle, this will be our regular area light that most DCC applications will have, so you might be familiar with this one. We can go ahead and scale this individually on the X and Y directions, and again, the bigger we make this, the softer our shadows will be, and we can make some really cool effects. If we look at our shadows here, we can also choose kind of the direction in which they spread. So maybe in around 90%, 80% of cases, I'm going to light up the scene by using this type of area light that's a rectangle. And finally, we also have a spotlight. Now, the spotlight is missing from our type list over here, and this is because we have to go to the shaping tab and turn the light into a spotlight. So I will enable the spotlight here, and now we can see we have some control. So if I drop down the angle, we can see our cone over here that controls our spotlight, and this is going to be based on our rectangle light. So let's maybe go ahead, let's disable normalize power for now and just increase the exposure a little bit, and we can play around with the softness and the angle. We also have some interesting options here to get a barn door effect. So we can see as I increase the left barn door here, the spotlight kind of closes on one side. Let's maybe increase this even more. We can kind of see this effect happening here. So really cool settings that you can play around with. And this will be some of the light types that we can use. And we can also notice that we have a lot of options here on the left where it says light tool. And these options are for allowing us to place our lights a lot easier in the scene. So if I go here to the diffuse mode, for example, I will set this to diffuse, and when I click on my object, we can see now that our light will be aligned on the normal of the object in the spot or place that I clicked. So if I want the light to highlight the shoulder, I can click over here and I can decrease maybe the exposure. Let's also maybe decrease the area light and the softness. So I can click on the head if I want to highlight this area of the subject. So it's really fun and very easy. We can see that as I hold down click, I can just choose a spot on our mesh wherever I want the light to be placed. Really, really handy. And we have some more options as well. While we are in our light tool, we can hold down, we can check out the controls over here. So if we hold down control and left click drag, we can increase the distance of our light. So we can either pull it further away or closer to our subject. So really cool as well. Control shift click and drag will increase the light intensity. Also pretty cool. And when it comes to, let's maybe zoom out and let's turn off the spotlight and keep this just as a simple rectangle light. We also have, if we press B and left click drag, we can change the size of our light on the width, for example. And if I press B again, I can change the height. And by pressing B again, we will go back in our normal light tool mode. So I can now continue to place this around if I want. So this is a really pleasant way to work. And there's another option for the specular and the shadow here. Specular has a little bit more to do when we are using very specular materials like a car paint or metallic surfaces. So we might look into that a little bit later, but more interesting will be the shadow mode. So if I click shadow over here, I can now click to place my light, and if I hold down shift and click, this will now determine where the shadows will be placed. So maybe let's say that I want to have some shadows on this side of the face of this character. I can maybe click to add our light over here, and with shift and click now I can determine where the shadows will be. So we can see how easily we can do some light sculpting and really highlight exactly the parts of our character that we want. So again, I'm holding down shift and click dragging across our mesh to determine where I want the shadows to be. So very pleasant and intuitive way to work in this manner. So let's go ahead now and maybe add a few more lights, and I want to show you one more node, which will be the light mixer. And maybe to navigate the scene a little bit easier, I'll go ahead and make this grid a little bit smaller. I can just go to the saw create here and I will set the uniform scale. Let's maybe do 0.3 or maybe 0.25. So now if I press F to frame in on this, we should have a little bit of an easier time when we orbit around the objects. So going back to the lights, we can maybe name this one, let's do key light, and let's copy this and let's add one more for rim light, and we'll do one more maybe for fill light, and I'll go ahead and merge all of these together. And now what we can do to control all of them at the same time, we can drop down a light mixer node. So I will drop this down and I will select with shift all of my lights and drag them over to this tab over here. And now we can directly change different attributes for our lights directly in this tab. And even better, we have a sliders tab as well, where we can control our lights maybe a little bit easier, and we have some more options over here. We can also, in this light mixer, we can cycle through all of these lights, and for example I can select my fill light and I can still use the light tool to position our lights. So maybe for my fill light, let's go ahead, let's determine where our key light should be. So I'm going to select this over here, and let's say that I want to have the key light maybe on this side, or maybe we can do it over here. Let's grab our fill light and this one should be on the opposite side, so maybe over here. And now I can also control the exposure through these parameters here. So the first one will be the intensity and the second one will be the exposure. So I can just bring this down quite a bit, and I can select my rim light as well and maybe turn this around and position this to the back of the character. So maybe let's do something like this. All right, and for the rim light I might want to make this a different color, so I can select this color picker over here and let's just give this another color so we can distinguish this. We can just use this pink color. And again, maybe I can choose the rim light position over here, or I can set this to shadow, and I'll set this over here for my contact point. And now with shift and click, I can determine where I want the shadows to be. So I can do maybe something like this, or maybe it's just easier to just use the regular diffuse mode. Alright, so we have some rim light action going. Let's maybe just move this even more. Alright, so now we have some rim light action going, and let's grab our key light. We can also maybe slightly thin this so it's easier to separate, and let's maybe turn down the exposure here as well. And I can also now from this light mixer solo or mute any of our lights. So if I just want to focus on my key light, I can solo it with this icon over here, and again I can just do my adjustments and tweaking. Maybe I can move this a little bit over like so. I can increase the intensity slightly, and now let's maybe solo our fill light, and let's make sure that this is selected before we move it. So I might move this a little bit, and we can maybe lower this overall so I can unsolo it and see all of my lights. And also we can mute any of our lights, so maybe we want to disable the rim light while we are working only on the fill and the key light. And really the light mixer now gives us a lot of options, and additionally we can still go to the attributes tab over here and set some values directly. So if I want, I can grab all of our lights and I can sort of reset them, and maybe I can set the intensity for all of them at 1 and exposure at 1, so I can do this sort of reset. And now maybe I can adjust each light from the start. Maybe I can grab the exposure of our, let's grab the fill light and increase the exposure, or actually this should be our key light. We can bring this up, we can bring up the exposure. Let's select the rim light, bring up the exposure for our rim light, and here we can solo or mute all of the lights as well. So really powerful way to work with this light mixer. And finally I want to show you one last node for lights, and we will have to place this somewhere else in our chain where we also have our objects in the scene graph. So maybe over here before our camera I will drop down a light linker node, and this works in a similar way as our material linker. I can make some inclusion or exclusions based on each individual light. So for example, I can grab the rim light, and maybe I don't want this to affect our Tommy character. I can now go to the right here on our geometry, go to our assets, and I will grab Tommy and place this inside the exclusion list, and we can see now that our rim light will ignore the Tommy geometry. So this is also sometimes useful, the light linker, when we maybe have multiple objects or where we want to include or exclude objects per individual light. We can also add volumetric effects to our lights, and in order for our lights to be volumetric, we first have to add an actual volume that can contain all of our light. And luckily Solaris provides us with a Karma fog box, so let's drop this here after our camera node. I will type here Karma fog box, so we'll add this here. Let's maybe also disable the geometry outline, and currently it's this container, so we can go ahead and increase the uniform scale here, and we can straight away start to see our lights are going to be scattered throughout these volumes. And we can also use the handles here, and usually this fog box should contain the entire scene. So if you have a camera in your scene, as we do in our case, we just have to make sure that all of our objects are contained within this fog box, or rather that our fog box contains all of the objects. So I'll press escape to hide the handles, and now we can see all of our lights have this volumetric effect to them, and we can also disable the light display in our viewport. So if we want, we can go back to our light mixer now, and we can play around with our lights. We can maybe grab our, let's grab our key light, and maybe I can increase the exposure here, and when we increase the exposure, this will naturally gives us more volumetrics in our scene. So if I increase this by a lot, we should see more of this light spreading throughout our fog box. Let's maybe go ahead and just focus on one light. I will go ahead and get rid of this light mixer connection. Let's grab our rim light and just plug this in our chain and just look at one light for now. We have a few options on our lights that we haven't talked about, and if we go to the Karma tab over here, we can see that all of these settings are grayed out, and in order to change any of these settings, so for example if I want to change the spread, we will have to go to this icon over here and choose set or create. And now as as I decrease the spread, we can see the different type of effects that we get. And the reason all of these options are grayed out is so that they are not stored onto the disk when we save out our USD files. So for example, if I were to grab this merge node and let's say that I wanted to save out the scene to a USD file as it is, if I drop down a USD ROP and save this out, all of these settings on our light will not be stored on our disk, and in this way we are going to create a file that has a lower size, so only the options that we change are going to be recorded. In this case, the spread is going to be written out to the USD file. So this is why a lot of these options will be grayed out, and these gray values will be pretty common throughout many other nodes. So it's a little bit annoying having to turn on the options so we can choose how to edit them, but once you get used to it, it's not that bad. And now, for example, if I want to disable one of these properties, we can just click on this icon and choose do nothing. So now this value will revert to the default and it will not be stored in our file. Now if we go back to our spread, we can control this nice fading of our light. So this is a pretty important setting. And also we can choose if we want to not have volume contributions for this light. So if I set or create on the contributions tab, here we can choose exactly which areas we want to affect. So we have diffuse, reflection, coating, subsurface scattering, so SSS, and we also have volume over here. So for example, this star symbol will mean that all of these areas are going to be affected, and if I want to exclude the volume from this list, I can do a caret symbol and I can type here volume. And now we no longer have this volume contribution on this light. So for example, if I were to bring in this merge over here, we have all of the lights contributing to our scene except our rim light. So if I were to remove this volume syntax over here, we are going to bring this back. Let's maybe go to all of these lights. Let's go to our key light and just change the color from over here, and also go in the Karma tab and let's decrease the spread a little bit so we can more easily distinguish all of these lights. We'll go to our fill light as well. Let's do our spread adjustments and let's actually preview it from our light mixer now. So now, for example, on our key light, let's say that we don't want this to be affected by our volume. We can go to the contributions, set or create, do our caret symbol and use or choose to ignore the volume. And we can see now that this got rid of it. So there's a lot of cool stuff that we can do with volumetric lights, and we'll maybe take a deeper look into it when we do our main project. We can also have lights in our scene from emissive objects. So let's go ahead and get rid of all of our lights for now, and I'll also disable the Karma fog box. So we currently don't have any light in our scene, and let's create a quick emissive material that we can assign to Tommy here. Let's maybe do a material library after our stage manager will go inside. Let's create a Karma material builder. We can just name this one emissive. And let's dive inside, and in our standard surface shader, we can go to the emission. We'll set this to a high value. Let's maybe use 10, and let's maybe make this a blue color. And we also want to introduce some white into this. So let's go up and let's assign this to our Tommy geometry. We will autofill materials. Let's assign to geometry, and here we can drag our Tommy asset, and we can see that the material works. So now if I do a render, let's go to the Karma render settings, we'll do a render. We can see that Tommy will now light up our scene. So maybe, for example, I can press S and I can select our Tommy object. Let's press T, and if I drag him around, we can see that the bounce lighting will follow him. So this will append this edit node that we talked about earlier. Let's go ahead and get rid of this and go back to our scene. And we can also see that if we don't have any lights in our scene, because technically our Tommy object isn't a light, if we don't have any lights, it will render with this annoying headlight display. And in order to fix this, we just have to add a light in our scene. And now we can see that even though we have this light and it barely has any contributions, we now have the correct result from our emissive material. I can even set this to 0, and now we can just focus on our emissive objects. And this adding a light trick here and setting it to 0 I do all the time when I just want to render out an emissive object separately from the rest. So I usually want to, if I'm doing a particle simulation, I usually just want to export the particle geometry and the light contributions of that particle geometry. So it's a pretty common trick that I do all the time to get rid of this headlight display. So now we can go back to our material, and if we step inside, we can increase the emission strength and we should see even more scattering of our light. But usually when we want to do this type of lighting with emissive objects, let's maybe set this back to 10. We have an option that Solaris provides for us. So if I go up, I will go after this material library, I will do a render geometry settings, and inside the primitives path here I will drop down our Tommy asset, and let's scroll all the way down. We have a lot of different options that we can play around with here. So for example, with all of these render geometry settings we can override a lot of our karma render settings. So maybe in the case for this particular object we don't want to render motion blur for it, so this is how we can override those options, and we can also access a lot of options that we have in the karma render settings now with limits and sampling. But the option that we are interested in here for our emissive lights, if I go all the way down, we can see in the light tab, we can see we have this option treat as light source. So if I set or create and set this to yes, now our Tommy geometry will be seen, as far as karma is concerned, it will be seen as an actual light and not a regular geometry, which means that our calculations will be a lot faster. So we can see that with our current sample settings, if I leave this a few seconds to render, we can see that for the most part we have a pretty clean result on our bounce lighting without that much noise. And if I were to set this to no, and again we are using the same sample settings and everything as before, we can see that we have a lot more noise on our render. So if we don't have this render geometry settings options for our emissive lights or our emissive objects, it will be a lot slower. So if we don't treat the objects as light sources, it will be a lot slower, but this is more physically accurate. And when we do treat the objects as a light source, this will not be as accurate, but it will clean a lot faster and nicer. And for the most part, we can see that there's really not that much of a difference between these two modes. So this is an extremely useful option, especially when you are doing effects. So later when we might do a particle simulation and we want the particles to reflect the colors they have onto our objects from the scene, we can use this option and have some really cool and fast results. Definitely one of the strengths of using Solaris is going to be the instancer. And the instancer will be a very familiar workflow if you are used to working at the SOP level with the copy to points node. So it's sort of like the SOP version, but we have more options when it comes to the instancer, and in general it's really powerful and you can easily scatter millions of polygons across your scene and have the scene running pretty smoothly. So let's go ahead, maybe we can just ignore our scene that we have here, and I'll just drop down the instancer node. And just like the copy to points, we have two inputs over here, only in the case for copy to points, we have our geometry that we want to scatter on the left and the template points on the right. And in the case for the instancer, the right input is actually where we are going to place the geometry that we want to instance. And the left input is basically for us to plug into our scene. So basically, if I have this scene over here and I want to add some instances, I can plug this pretty much wherever I want. Of course, this depends on how you set up your scene, but I can just plug this over here, for example, and now this will error out because we actually need our points that we want to use as our scatter points. And to create the points, we actually have to step inside the instancer. So I will double click, and here I can just drop down a simple add node and create one point at the center of our scene. Let's maybe press D and go to the guides here, and or rather the geometry, and I'll turn up the point size so we can clearly see the point. So we just have one point, and if I go up, we can now provide some geometry to scatter. So maybe I can just drop down a simple cube, and if I plug this over here, we can see our result. And in our scene graph, if I go at the karma render settings node, we should see our instancer over here. We can see that the type is a point instancer, and inside here we will have our prototype prototypes, so the geometry or objects that we are scattering. So our right input will be for our geometry, and the left input is simply to plug in our chain. I can, in fact, if I were to disconnect this node and just have our cube, the instancer will still work. We can see this over here. Maybe let's just focus on the instancer as it is without worrying the rest of our scene. We can see it here in our scene graph. So for example, if I were to go inside, I can grab this point, press enter, and I can move it around. I can maybe add another point. Let's move this one around, and let's create one more point and also move this one. So we have now 3 points. Let's maybe move this one, grab this one in the center here. So we have 3 points, and when we go up, we should see we have a shading error here. Maybe I can go ahead, and sometimes if you have some weird bugs in your viewport, it's always worth going to the labs here, and I will just reset the viewport, and now we have the proper result displayed. And a common way to work with the instancer, I can pin the viewport to our top level, which will be our stage context. And when I step inside the instancer, here we are actually at the SOP level, where we can do any type of SOP operation. So that's really great. I can also now see directly inside the stage context what kind of changes we are doing. So now I can maybe modify my points position by using these transforms over here. So you will probably not going to manually place points like this, but what you are going to do is assign attributes for the points. So most of the attributes that are recognized by default for the copy to point SOP are also going to work for the instancer. So for example, we can have p-scale on our points, we can have normals, orient, and pretty much all of the attributes again that work in the regular copy to points node. So for example, I can do an attribute randomize on our points. I can set this to p-scale, and we can see now we have a random value between 0 and 1. I can adjust my attributes now, and we can also do another attribute randomize. I can set this to n, which is our normal. I will set this to direction or orientation, and now we also affect the orientation of our copies. So this is really great. Now let's go up, and let's say that we want to instance different types of geometry. So for example, I have a cube here. Let's also drop down a cylinder, and maybe we can also do a sphere. Now I will merge all of these together. Let's drop down a merge, and let's just preview our merged result. I'll plug this over here and here as well. And now we have our cube, cylinder, and sphere in our scene, but it's worth setting up some proper paths for all of these meshes. So let's go to our cube and let's just place this inside. Let's maybe do something like asset, geo, and I'll do cube. So we have a directory assets, a subdirectory geo, and our cube, and I'll copy this path to our cylinder, only rename this end component here to cylinder, and finally for our sphere as well, let's go ahead and do sphere. And if I look at my merge now, we have all of our meshes inside this assets and geo folder. So if I go to the instancer now, this will give us the result that we are looking for. So in our prototypes here, we can specify the prototypes that we want to copy, and by default this will give us an expression which fortunately for us evaluates to all of the assets that we want to copy. So we can see we have the cube, cylinder, and the sphere, and in the options tab here we can also specify the prototype index. So if I just want to copy the sphere, I can set this to index. Or actually, if I just want to copy the first one, which is index 0, this will mean that all of our instances will be cubes. And if I set this to 1, we have our cylinder. And if I set this to 2, we have our sphere. And by default, this is set to random, which will cycle through all of our variations. And I can change the seed now to have a different type of distribution for our instances. We have some weird issues going around. And this is, again, a viewport bug. If I reset the viewport, we see the correct display on our geometry. Now, this works, but most of the time, we want to be more specific with the prototype primitives that we want to copy. So here, instead of leaving this with the default expression, I will do assets. And inside here, I will do geo, and I will want to grab all of the components inside this group. So I will do a star symbol. So now we have the same result. And I'm doing all of this to show you that it's very important to take care of what path we are placing over here. Because, for example, if I were to remove my star symbol and the slash and just look at our geo, now we can see that for each of the points on which we instance our geometry, we are actually bringing our our whole geometry that contains all of our different meshes. So we are just looking at this geo right now as it is. So it's sort of like if I were to collapse this, we are just looking at this as the object to instance, and it will naturally bring everything that's inside of it as well. So it's very important again that you specify what you want to copy. So if I want to look through all of the components of this geo group individually, I will have to do slash and then do my star symbol. And now we can see we have the result that we would expect, and we can change the seed here. So this is how we can use the instancer. We can also use the instancer with assets that have variations. So for example, I can go ahead and let's just copy this instancer. So here we just have our 3 random points that we placed in the scene. Let's place this all the way up and go to our component builder, which we use to create a USD asset that also has variations. So here where we worked on our hero asset, we included some geometry and material variation. So again, if I wanted to, I can do a set variant, and for the geo set, I can choose one of the other variants that we have. So let's say that maybe I want to scatter a random variant per point. What I can do is, let's get rid of this, and from the component output here, and again, I can just save this to disk and I can load it as a reference. So if I grab the path that I used over here, I can just load this as a reference, and here we have our hero asset. So maybe I can just use it like so. And if I want to use this inside the instancer, first we will have to expose all of our variants. So we can do this with an explore variants node. And here for the mode, we will set this to explore variants. And by default, this will load out all of our variants that are spaced equally between each other, so we can see them over here. But in order to use them inside an instancer, and this is true for the copy to points as well, we need our objects. In 99% of the time, we need our objects to exist at the world origin. So I will set the spacing here to 0, so they're all stacked on top of each other, again at the 0, 0 coordinate. And this node will create a group for us called Explore Variants, in which we have our hero asset. And now our hero asset is broken up into all of the respective variants. So I can plug this inside the instancer. And if I go to the instancer, we will have to update our prototype primitives path here. So let's do slash explore variants hero, and inside here I want to cycle through all of these components, so I will do star symbol. Now this doesn't work right off the bat, and if I go to the information here, we can see that the primitive is embedded in a composition arc. Now without getting too much into USD specific details, if I go to the explore variants, we see that this primitive here, explore variants, is highlighted in green, which means that it has this composition arc. And all this means is that we need to flatten this layer in order to use this in the instancers. So here after the explore variants, I will do a configure layer. And if I go at the bottom here, we have this flatten input, and let's choose flatten input stage. And now we see that the explore variants is no longer green, and we can use this in our instancer. And now we only have our pyramid for some reason. Let's go and change the seed here. We had a weird seed where all of them were just the pyramid version, but if we change the seed, we can see that very easily we can cycle through all of our variants. So again, by just using one USD asset with variants, we can very easily populate an entire scene, especially if we are using the instancer. So for example, if I go inside, let's create maybe some points that kind of make more sense. So I can just drop down a grid, and we can use this grid as it is. We can see that automatically this worked. And by default, this will just use the points of our grid. So if I unpin the viewport, this is the grid, and we are just going to look at the points. And now from here, I can either use the grid, or I can do a scatter and align. I can maybe increase the coverage here. I can do some minimum and maximum radius scale. And let's again go up and pin the viewport to the top level, go back inside, and we can preview now our changes in the stage context. And I can change the angles here. So the rotation, let's increase the max angle. We can do all sorts of stuff. So again, attributes like p-scale, color, orient, normals are going to be recognized by our instancer by default. So we are going to use a lot more of this instancer in the main project, but this is just a short introduction. The instancer is very powerful. I use it all the time. It's super easy to populate entire scenes. And again, it's one of Solaris' biggest strengths, I would say. When it comes to scene assembly, aside from the instancer, we also have a layout node, and let's go ahead and just drop this down in our scene. Again, let's maybe just place this down, and I'll drop down a grid before it, and let's link this up like so, because the layout node works better if we already have some geometry in our scene. Again, we can place this layout node wherever we see fit in our chain, but we can just focus on this grid for now. So I'm not a huge fan of this node. I found it kind of hard to control at times, and in general I didn't have the best time using it. Maybe I haven't used this enough, but I always seem to prefer working with the instancer instead. But let's see how this works. So for the layout node, we have a few options that we can use to scatter instances, but first we will need to load in our objects over here, and we can load them through our layout asset gallery. And if you don't have this window, you can hit this plus, you can go to new pane tab, and you can go to Solaris, and here you will find the layout asset gallery. And again, Solaris provides us with this default library that we can use, and you can create your own libraries. You can, for example, whenever you use the component builder, you can also store a thumbnail and add it to a gallery. So in our component builder setup that we had earlier, here we have our component output. We have this option here. After we save it out, we can also save out or generate a thumbnail, and then we can load this asset in our layout asset gallery and very easily build libraries for ourselves with assets that we can reuse in all kinds of projects. So let's go back to the stage here, and let's go back to our layout node. So from the layout asset gallery, we can go ahead and I can click one of these items and hold down shift, select all of them, and we can just drag them in our list over here. And now the way this works is we have to select what items we want to place. So for example, if I want to place let's do this barrel, I will just click this check icon over here and the default mode will be place. Let's also step back into stage. And now if I press enter, we can click and drag to place our elements. And when we are dragging, we can control the scale, and by dragging the mouse around, we can also choose the orientation of the object. Now this by itself is pretty cool because we can see that automatically it's going to be placed on the normals on an object. So for example, I can do something like this and we can build some pretty complex assemblies like this. So for example, now I can uncheck this one and let's maybe bring in our peak head. Let's hold down click and place our peak head. And now this one is in the center of our scene, so it needs to be on the ground. Let's maybe choose one of these other barrels. I'll choose the wine barrel over here, and we can see we still have our peak head. Let's undo this and also our first peak head that we chose, and let's make sure that our peak head is unselected and we only have this wine barrel selected. So we can click and drag to place this one, and while we are holding down click to drag, I can also hold down shift to readjust the position of the barrel. So this is pretty cool by itself. And we also have a radial menu for this brush. So for example, if I want to delete certain objects, I can press C and I can choose the mode here to delete, and now I can click on the objects that I want to delete like so. And it's honestly not the worst to work with, but I would still prefer, if I'm hand placing objects, 90% of the time I would still prefer to do it with the stage manager. So this is the place mode, and we also have a few more modes here. Let's say that if I want to scatter a bunch of objects at the same time, I can hold down shift and select all of these, for example, and I can choose, let's look at the paint mode, and we can use our scroll wheel to select the radius here, but we'll also probably have to scale down the radius as well. So now I can hold down click and I can paint where I want to place my assets like so, and this will automatically cycle through all of our selections. So maybe I just want to, let's uncheck all of these ones and only keep our barrels. And now if I hold down click, we can paint wherever we want to scatter these assets. This is also pretty cool, and we can see by default this will give us a point instancer with our prototypes. So that's probably what we want in most cases. But the reason that I don't like the layout node that much is because it's harder to control the instances after we set them up. So it's kind of hard to control their orientation. Maybe I want to modify their p-scale, and usually I want to have all of those options. Now there's probably some ways in which we can control this after we set them up, but again, it's just not my preferred method. If I want to place things manually, I would use the stage manager. So for example, for my hero assets usually. And if I want to scatter instances like this, I would just use the instancer mode. And for example, if I go back to our setup here with the instancer that's scattering all of our variants, let's step inside. And if I wanted to have a more specific setup for the scatter, let's unpin the viewport so we see our geometry. Let's say that we have our grid, and I can just give this grid some resolution by increasing the divisions here, and now I can just do a paint mask SOP. Let's hit enter. I can scroll up to increase my radius, and I can just determine where I want to place my instances. So very easily I can draw an attribute on my mesh, and now if I do a scatter, I can use the density attribute here, and we can make this look at our mask attribute that we created. So we only have instances where we drew our mask. So now I can go up and we can see them over here. So if I pin the viewport to the top level, I can go back inside, and now I can do an attribute randomize. I can control my P scale, so I can set the global scale to maybe something a lot lower. I can control the minimum and maximum values. I can also do an attribute randomize for the orientations. So I'll set this attribute name to N. Let's do direction or orientation. So now each of these have a random orientation. And as I keep working, as I keep adding stuff to my chain, let's maybe add a light as well, place this here. Now I can always just go back in my instancer and I can change the copies. I can maybe scatter less instances if I want. So this is a lot more procedural, a lot less destructive. And in general, I think this is the problem with the layout node, that it's maybe too destructive for my taste. Maybe it's my own personal bias. I'm sure there are some artists out there who really like this layout node, but for me personally, I tend to avoid it as much as possible. But really, take my opinion with a grain of salt. I'm not a layout engineer master by any means. So if you experiment with the layout node and you like this workflow, definitely go for it. Let's see how it all comes together and use all the knowledge we have now in Solaris to create a simple scene from scratch. And in order to showcase as much as possible of the potential of Solaris, we are going to create all the assets necessary to build this scene entirely in Houdini, so we are not going to be importing any third-party assets. And this is to showcase a lot more of the power of the component builder and how it can all really come together and give us a smooth and seamless process. Now, we can start directly at the stage level, so I can hop over to the LOPS context over here. And we can drop down a SOP create to start placing down elements and start to work on our layout. The only problem with doing this is that we are pretty limited in our camera capabilities. So when it comes to creating a camera and especially animating a camera, I would much rather do it at the SOP level, so in the object context, because I personally like to work with a lot of null parenting and create some very simple camera rigs, and it's a lot easier to do at the SOP level. And while we are at the SOP level, we can also place down some simple elements that we can then bring into Solaris, and then from Solaris we can bring the elements that we need back over at the geometry level and so forth. And this is mainly if you are a solo artist and you are working on your shots from scratch. It's overall just better to start at the SOP level, and it's also just more comfortable for me either way. So let's go ahead and we can start by placing down a grid, which will be our ground essentially, and I can rename this maybe to Geo Ground. Let's go ahead and we can also drop down a test geometry Tommy for reference. So it's always better to throw one of these down so we have a nice reference for our scale. Let's go in our Geo Ground, and on our grid, I'll maybe show up objects here and I want to increase this. Let's maybe do 100 by 100. So I think this should be plenty, at least to start with. And we will, if we press Shift W, we can see that we might need more resolution because we are going to do a little bit of modifications to this grid so that we can build the crevices or the place where our river can flow. Maybe we need more. Let's do 250 by 250, and this should be enough. Maybe we don't even need to go this high, but I will leave this as it is. And I want to be able to procedurally place where I want the river to be. So I will do a draw curve on the right here, and I will template the grid with E, and I will set the display flag on our draw curve. And for projection here, I will choose ZX plane, which is flat on the ground. And now if I press enter, I can simply hold down click and I can draw a sort of like an S shape like this. From here, we can do a resample. And I want to divide this curve into just a few points. So if I turn on the point display, I will increase the length here by quite a lot until we just have only a few points, maybe something like this. And now we can convert this to a NURBS curve. So let's drop down a convert. I will set the convert here to NURBS curve. And now if I place this inside a curve node, I can press enter in my viewport and I can press F and select these control points and continue to shape my river area however I want. So maybe I can do something like this. It's also important to note that we might move our points on the Y direction as well. So we always want this curve to be nice and flat on the ground. So from here we can do another resample, which will turn our NURBS curve into actual geometry on which we can add attributes. So we will need this later down the line. And from here we can also drop down a transform, and I will set the scale here to 0. So again, it will always be nice and flat on the ground. So from here we can use this curve geometry with our grid, and we can use an attribute transform to determine a gradient on this grid based on the curve. So in order for the attribute transfer to work, we will need to set up some attributes, and usually for this I like to use the color. So I will set the color for this grid, I will set this to black, and the color for our curve, I will set this to white. And now when we do an attribute transfer on our grid, let's plug the curve as our second input, and maybe we can actually name these as well. This will be our curve and this can be our grid. If we go to the attribute transfer, we already see our color transferring. Let's disable primitive transfer here and only keep our points and specify that we want our CD. So now with our blend width, we can control this fading of our attribute, and our initial distance threshold will determine exactly how much we want to spread this attribute. So we can see between these two values we have a lot of control. Let's keep these as it is for now, and we want to use this color attribute to push our grid downwards. So we can do an attribute VOP. Let's rename this one to, let's maybe be specific here and say that this will be our push down operation. We'll step inside and we want to grab our color. And because this is a vector, we want to turn this into a float. So let's do a vector to float from here. I will plug the position back inside the position as it is. And now I can use either of these values to create another vector that we can subtract from our position. So let's just grab the first one and we'll do another float to vector, and we want to plug this as our second input on our vector. So now if we do a subtract from here and I subtract this one, we see that our ground is slowly pushed inside. And now all we have to do is simply scale this vector that we created here. So after the float to vector, we'll drop down a multiply, and I will just promote the second input here, and I can rename this one to, let's say, push amount. And now I will go up, and if I go to the push amount, I can determine exactly how much I want to push down onto our ground. And we can now, after this attribute VOP, we can do another color node and reset our color to white, so we get a more accurate display of what's happening with our geometry. And now I can also go to the attribute transfer. I can control the overall distance. I can control this blend width to smoothen out this transition. So maybe we can do something like this. And the coolest part here is that we can go to this curve node over here, and I can grab the points and reposition where I want this river to be. So this will come in handy when we are going to drop the camera down in a second, and it will overall allow us for a much easier layout, and it's always just nice to keep things as procedural as possible. Now of course we can also add some noise onto this ground as well, so from here we can just do a simple mountain node, and I will go to the noise pattern here and just increase the element size, and I will keep this fairly simple. I will just increase the amplitude maybe, and we can do something like this for the most part. This should be fine. We can drop down a null and let's call this our out geo ground, and we can go up and we can also create our river, or let's just call it water for now, and this will be very simple. We just need a grid basically. So let's drop down another geo container, and this will be our geo water. We can step inside, and again we'll just do a simple grid. We will increase the size to 100 by 100 so it contains this entire scene, and here we can leave this as it is because we can do some displacements on this geometry, but it's better to just do this through the material directly so we don't have to compute all of this geometry in our scene and only have it affect our geometry at render time. So let's drop down a null from here, and this will be our out geo water, and we can also just do a simple color node here, and let's just set this to blue so it's easier to work on our layout. Now for the most part I would want to keep the water level directly on the ground floor, so I don't really want to push this down. I could just drop down the center here like so, but I would much rather have this on the ground so we have this direct reference where our ground floor is, and I would rather push the ground geometry up instead. So let's go up and let's go back in our geo ground, and here all we have to do is append a simple transform and push out our translate y coordinate. We can maybe do something like this. We'll have to come back to all of these settings when we create the camera in a second. And on that note, I think we do have enough for now in order for us to start working on our camera. Maybe I will go to the attribute transfer here, and some of the things we can play around with is going to be this kernel function. If I go to the attribute transfer display, let's just hide other objects. We can try maybe another model here that's a little bit more smooth, and maybe we can preview this from our color node. If I go to the attribute transfer, we can cycle through some of these models. Let's maybe choose blend and increase the blend width. We can do something like this. Go back to our geo ground. So this is looking slightly better. Let's also preview our river as well, and I might want to overall just bring this even more to maybe something like this. I can of course go back to the attribute transfer here and just increase the overall spread of this river. So again, we have a lot of controls to do whatever we need. So now I can go up and I can start working on the camera, and because I know I want a camera that's orbiting, we can also, and speaking of which, we can also do another geometry, and this can be our focus element, which is going to be the particle effects. Let's call this one effects ball reference, because we just want to drop a simple ball in our scene that will act sort of like a placeholder for our effects. So let's go inside here and just drop down a simple sphere. I'll make this polygon, increase the uniform scale here and the frequency, and maybe make this another color so we can easily distinguish this. I'll maybe make this pink or maybe green, and I will want to do a transform here and also bring this up so it's above our river. And the scale here matters as well. So if we look at our sphere, let's maybe reset the radius so it's 1, 1, and 1, and now we have a uniform radius of 8. Probably this is too much. We want something like 3, but we can also come back to this later. Let's also go to the transform here and bring this up even more. And now we also have this effects reference, and we can go up, and now we can actually start working on the camera. So to create this orbiting camera, we can drop down a null, and I will name this orbit. So our null is currently in the center of our scene, and this is where I want the camera to orbit around. So if I drop down a camera, let's go ahead and I will hit enter here and bring this camera out by quite a bit, maybe something like this. We can currently see this because of our geometry, so I will press W and we can see this camera here, and it's pushed into Z space, let's say maybe 25 units away. If I now simply parent this to our orbit null, if I now grab this orbit null, I can use the Y rotation here to orbit the camera around the center of our scene. And I can also bring up this null and our camera will follow as well. So we can see with this, we can control the height of our camera and our Y rotation will control the orbit. So now I can step inside the camera. Let's go ahead and right away we need to set up some settings here on the camera. So for the view, I will set this to 1080 and I will also want to decrease the focal length so it's a little bit more of a wide angle, maybe 22 will be good in this case. And again, if I go to the orbit, the translate Y will control the height and the rotate Y will control the orbit. And also a cool thing we can do with this orbit null, if I step outside, we can also use the uniform scale to either push in or out with our camera. So if I look through the camera, this looks something like this. So this is also something very useful. Now, to get some further controls, I would also like to have a null in my scene that controls where our camera is looking at. So I will drop down a second null here to the side. I will name this one to target. Let's maybe do target cam. And in order to have our camera look at our newly created null, let's select our cam. We will go to the constraints here at the top. I will choose look at. So click on this look at. Now I can grab my target null, and while hovering over the viewport, I will press enter and I will press enter one more time, and this will create a constraint network inside our camera node. So if I go up, we can go up one more time and all of this will be inside our camera, as we can see. But now if I grab this target null, we should be able to see, if we look at our camera, if I grab this up, we can see now that our camera is pointing where our null will be. So if I go through the camera view, if I grab now this target cam, I can also direct exactly where I want this camera to look at. So this is usually how I like to set up a very quick rig for our camera, and this provides for us a lot of options. So with this target cam, I want to avoid having the horizon line right in the center of the scene. So maybe I will just bring this up a bit. I will also go to the orbit here and I can angle this camera to be closer to the ground. Maybe a value of 2 will be good here, and then I can maybe grab the FX ball reference here and I can maybe move this up slightly, and now I can start to animate this camera. So I will start by going to the orbit null and I want to push in our camera. So we will go to the beginning of the timeline. Let's add a keyframe with Alt and left click. I will go to the let's maybe just make this one 120 frames. We don't really need 240 frames just for a demonstration. So I'll set the timeline here to 120 and I will just decrease the uniform scale. And now this will mean that our camera is being pushed in like so. And we create this animation. Let's shift click the uniform scale and press F to zoom in on our graph. Grab both of these keyframes and I will set them to linear. By default, all of the keyframes that you add in Houdini are going to have this Bezier smooth interpolation. So in the case for the camera, I usually want to have a linear keyframe interpolation like this. And because I'm going to work a little bit more in this keyframe editor, let's go ahead and close this and I will move my graph over here to the bottom. I'll do a new pane tab. Let's go to animation and animation editor. And now here I can press F to zoom in on the keyframes and do further adjustments. So let's go to the beginning of the timeline again, and we also want to orbit around. So let's start maybe at around this angle, add a keyframe. We can see that this will automatically bring it in the animation editor. We'll go to the end of the timeline and I will increase this rotation value and we end up with something like this. Again, I will grab the rotate Y here, press F, grab this keyframe and choose linear interpolation. So let's preview the animation and also toggle real time in our timeline. And this is the result. So it's looking pretty good. We can maybe push our camera further in. I can grab the uniform scale value. Let's press F and we can just bring this value down even more so we can again increase this kind of pushing animation. Now, I also don't really want to spend too much time finessing the camera because it's not really the point of this course. So for now, the simple animation will do. And one other thing that I would like to show is how to add some noise based on our look at null. So we can add a little bit of camera shake if we add some noise to the translate values here. Let's right click, let's go to motion effects, and I will choose noise. And if I look at animation, this will be too much by default. So I will decrease the amplitude, increase the period, and also decrease the roughness. And now we end up with something like this. Maybe we can increase the amplitude more, decrease the period. So it's going to take a little bit of adjusting and finessing, but we can very easily introduce a little bit of camera shake as well. Also, we can, let's go up and let's go back inside the camera here where we have our constraints. We'll go inside the constraints, and we also have this twist value here, which controls the tilt of our camera. And we can also maybe animate this or add a simple noise expression. If I set this to 0, we can right click and also choose a noise over here. We can see that by default this is maybe too much, so again we will increase the period and decrease the roughness and maybe decrease the amplitude as well. So now we also have a slight tilt, and this should be more than fine for our purpose. So let's go up all the way to the top level, and this can be all of our camera rig. I can select all the nodes and press Shift O to draw a network box, and this can be our camera. So now we have pretty much all of the elements that we need as far as SOP level is concerned, and we can slowly start to bring everything in Solaris and start to populate our scene. So we have everything we need, and we can step over into Solaris. We can dive over to the lobs, so in stage, and we can bring all the elements together. If we do a scene import, we see that we have different presets of this node. We have scene import all, so if I drop this, we can at this point also go to one of our Solaris desktops over here. So let's go to the Solaris mode that Houdini provides us, and when we do our scene import all, we bring in our camera, so we really bring in all of the objects that we have. If we go to our camera here, we also have our camera animation, so everything is working. Now, I don't really like working this way. We can use this if we want, and we can append a stage manager from over here, and we can reorganize our chain in however way we want. But usually what I like to do is keep things as separate as possible. This way I found it's easier to have individual treatment for each element. And again, this is more concerning the workflow if you are working as a solo artist. So let's go ahead and get rid of this, and let's just bring in our camera first. We can do a scene import, and we can choose the cameras preset. Let's drop this here, and by default this filter will be set to cameras, and here to the objects, let's also make sure that this is pointing just to our camera. So we will hit accept, and if I look through the camera, we have now our camera. Let's go ahead and bring the elements now one by one, and we can bring them with a SOP import. We can go back to the object, and let's start with our geo ground. We'll step inside, grab our geo ground. Let's also make sure that we are not bringing any unnecessary attributes that we might have. We just have the color for now, so this won't be bothering us. But in general, it's just a good habit to inspect the geometry that you are bringing in, specifically as it concerns the attributes. So let's grab this, Control C to copy this path. We'll go over to lobs, and we'll do a SOP import. We'll paste our SOP path over here, and now we can also start to decide how our chain will look like. For now, we can do a simple merge with our camera. We'll bring all of these elements together. We see we have our camera with the orbit in our scene import camera. If we just want to have the camera, we can flatten hierarchy, and now we just have this cam 1. So we can do this if we want. I don't think this is necessary in our case, but for our SOP import here, we can start to decide how we want to organize our scene. So we know that we want our initial ground geometry, and I will want to scatter some grass on this ground, and we will also have the water. So all of this can be inside a ground component, and this ground component can be part of an environment assembly. So let's go ahead here, and for the import path prefix we will do env with capital letters, then we will do ground, and we will place this inside a geo directory. And now if we look at our chain, we have this ENV that stands for environment, our ground, and our geo. Let's go ahead and we can also, let's rename this to ground, GRND. And now I can duplicate this node and let's bring in our water. I'll change the name here and let's point to our, we will go inside our geo water, and here we will select out geo water, and this one we will place inside env/ground/water, and we can start to merge these two now together. So let's drop down a merge, bring in our water, and here it is, and our main chain. We can also just drop down a null from here, which will signify the end of our graph. Let's do out scene. So we have our orbit, then we have our environment, and inside here we have our ground, which has our geo and our water. So we will place our scatter grass inside this ground group as well, but we will do this later. For now, we can start assigning some materials for our ground geometry that we have and our water. And this might be more part of the look dev stage of building a scene. Probably first we should place more elements and figure out the layout more, but I usually like to start working on the materials pretty soon. So with that being said, we can go ahead and for our ground, let's drop down a material library. We can step inside. We'll do a Karma material builder. Let's rename this one to Geo Ground. And for now, let's step inside and let's just change the color to something like dark brown and desaturate this quite a bit. This looks all right. Let's go up and let's see where we will place our materials. So let's also place this inside the environment and inside the ground group. So we will do env/ground, and then inside this ground we will do materials. And now we can autofill materials to bring in the material that we just created, and we don't want to override the path here, so I will get rid of this material path. So we're just using this one instead. We can also now use the material builder to directly assign to the geometry, and we can probably just grab our geo from over here and drag it over, and now we see it in our scene. And we'll go ahead and let's just copy this material library and assign this to our water. I'll step inside, and for this material builder, I will rename this one to water, and let's step inside this one and make this one blue. So I'll change the color. Let's go up and let's update the paths here. I can just leave this one in the ground group as well, but here we can see that the name of the material VOP has been updated to water as well, but now we will just have to assign this to our actual water primitive. So I will drag the path over here, and here we have it. And now from our merge or before our out scene, let's just do a simple Karma physical sky, so we have a light in our scene. And spoiler alert, we will also use this Karma physical sky as our actual final light that we are going to be using. So we're not going to spend too much time on look deving our lights. We are going to keep this simple and just use a Karma physical sky. I will set the exposure to a value of 2, and we can go ahead and press Shift R to start previewing some renders. Let's set this to Karma XPU, and I will change the angle here to maybe more of a sunset kind of look, and also I can maybe move this around. We can also preview through our camera, and this is what we have so far. So let's take care of our materials. Let's start with our water, which should be extremely simple. We can do this while we are previewing the render directly. Sometimes this might crash, so you might not want to edit the materials directly in the render view. You might want to just use the viewport and start rendering after the changes, but this is a simple enough scene that we shouldn't have a problem. So let's step inside, and in our material builder, I will go ahead and get rid of the color. So we'll set this base to 0, which will mean our color is completely black, and inside the transmission we want to turn this all the way to 1, and now our water is completely transparent. And also I will slightly tint this color here to maybe something like a blue. Let's do this, let's have this more desaturated, do something like this, maybe brighter like so. And also I will set the depth here. I believe this uses values related to our world units. So if I'm looking at the water, maybe this depth here should be around 1 or 2 unit lengths. So let's set this maybe to a value of 2. And this is mainly affecting our color. Maybe if I were to set this to a more saturated value here, we can kind of see our depth value will slightly shift the color towards the intersections with the geometry. So if I set this to 0, I'm not sure how noticeable this is over here, but when I set this to a value of 2, this will now bring in a little bit more of our geometry color, which is something that you usually want. Now also in our specular, we will want a specular value of 1, but we want 0 roughness. And for the index of refraction, I believe water has an index of 1.33, but really here we can just play around and we can have some creative freedom for the most part. So we can just set this to a value that works for our scene. In this case, I will just leave this at 1.3. And now we can also set up some noise for this texture, and we can either do this as a displacement, but in our case, it's not really worth doing this as a displacement because we need such a subtle change in our geometry that it's going to be faster and more optimized for us if we set up this distortion as a normal bump map. So what we can do is drop down a fractal pattern. So we will use this MTLX fractal 3D. And if I wanted to see how this texture looks, we can assign this to a unlit, so a MTLX surface unlit, and I can plug this result, so the out over here, I will plug this in our surface and we will have a direct representation of our pattern. So now in our fractal noise settings, we have some values that we can play around with. So we can increase the amplitude, we can make this more rough or more soft, but we see that we don't have an option for the scaling. And this is because this fractal noise will be by default mapped to our world units. So if I do from here an MTLX position, we can set this one here to world to reference our world units. And if I plug this in the position, nothing will change, but now we have the option to scale the coordinates for our noise. So if I do from here a multiply, so MTLX multiply, all of these nodes will need this MTLX in front of them. So only the MTLX nodes will work in this Karma material builder. So with this MTLX multiply, I can now stretch this in any given direction. So I can either use the X component here or the Z one. So this is how we can control our noise. And maybe I will just increase the Z value over here and maybe increase this X component to 0.3. Let's do 0.3 and 2. This should be all right. And one more thing with the fractal noise, this by default will give us values between -1 and 1, which is going to be, I think it's going to be all right in our case because we want to use this as a normal bump. But oftentimes you don't want to be working in the negative ranges. So from our fractal 3D, we can also do a MTLX remap, and we can remap this from -1 and 1. And now this will sort of normalize our fractal 3D pattern. And now we can also animate this noise on the Y component, similarly to how we would animate a turbulent noise in an attribute VOP at the SOP level. So after our multiply, let's go ahead and drop down an MTLX add. We'll drop this here and we can add to our second component. If I were to increase this slightly, we can see how our noise pattern changes in the viewport. And we can link this to our time, again, similarly to how we would do it in a VOP node. So let's drop down an MTLX time, which will grab the time in seconds. And we will need to create a vector from this because this is by default a float value. So from here we can do an MTLX combine. Let's do combine 3 versions and we can place this in our second input, which will correspond to the second value here inside this MTLX add. And now we can place this as the second input. So now as I scroll my timeline, we should see our noise evolving. So it's unfortunately kind of hard to preview this in real time. So what we can do instead, while having this render mode active, and I'm using Karma XPU, I can go to the flipbook properties over here. Let's right click, let's do flipbook with new settings. And when we are in Solaris, in our flipbooks tab here, we have a option that says limit frame times. And with this option, we can decide how much we want our renders to run per frame. So in our case, I only really want them to last for a split second. I can set this to a very low value, like maybe 0.2. And let's go to the size here. We can leave this as they are. Let's hit start, and hopefully now we should have a flipbook and that runs really fast, and we can see that we are just blasting through all of these frames. And now if I play the animation, I can see how fast my noise is evolving. So judging by this, I can say that maybe this is evolving too fast for my taste. We can maybe use half the speed. So I will close this window, and let's go to our MTLX time here, and we can just do a divide and divide this value by 2. So now this is moving twice as slow, and we can run another flipbook if we want, but I'm pretty sure I'm happy with this result. So we can play this, and we can see that now this noise evolution is a little bit better. So let's go ahead and close this, and let's see how we can add this as a normal map. So over here, where we have the last node before we plug this into the surface, we can actually go ahead and get rid of this connection, and we can plug back our regular standard surface that we set up earlier. This was just for previewing our pattern. We can grab the result of our fractal 3D with this remap, and by default this will give us a 0 to 1 float value, and we need to turn this into a vector value, and for this we can do a height to normal conversion. Now we see that we will output a vector information, and we can plug this inside a normal map node. And this is similar to how you would bring in a normal map texture, so an image texture. You would have to filter this through this normal map node first. And now with this, we can place this inside the geometry and inside the normal input. And we can see it over here. By default, this value we can see is pretty high, and we can go to the height to normal here. And this scale, I believe, is also referencing world units. So it's trying to fake a depth of this mesh that's 1 unit in size, which is pretty big in the case for this river. So we want something really small. We can maybe do something like 0.05. And now we see that this looks a lot better. We can also maybe preview this through our camera. And this is the result that we have currently. We can experiment maybe with different scales here. We might not need to go as much, and maybe we can also scale or stretch this noise a little bit differently. We'll go to our multiply after the position, and we can maybe decrease our third value over here. Let's maybe try 1. So I would say that this is fairly decent. And again, if I want to preview the speed, I can do a flipbook, so we can decide how fast we want this noise to animate. But we are more or less done with the river, and we can go up, and let's go now to our ground geometry. So inside this material library, we'll go inside GeoGround, and the first thing that I want to do is increase the roughness in our specular channel. So let's go over here and make this really rough, maybe like 0.85 or so. And this should be good for now. And for our base color, we can use another fractal noise for this as well. Let's go ahead, and because we know we want to control the scale of our pattern, let's go ahead and just start right away with an MTLX position. We'll plug this inside a MTLX multiply, and we can plug this inside a fractal 3D. And with this noise, we also want to normalize this. So let's do an MTLX remap and set the in value here to -1, and in high should be 1. If I plug this inside the base and inside the base color, we should already see this pattern here. And now we can go to our multiply. And if I want to scale all of these values at the same time, we can choose the signature here, vector3 FA, and I can decrease the input, and we can see how this increases the pattern of our noise. Also for our base color here for the fractal, it's worth adding more roughness in this noise. So I like to increase the octaves here to 10 and increase the diminished value, and we can see how easily we can add a lot of roughness in our noise pattern. Also, I would like to map these black to white values to some different colors. So after the remap, we will do a karma ramp constant. Let's go ahead and choose our first color to be something something like a dark reddish brown, and our white color, let's map this to something more light and desaturated, but also probably a little bit dark as well. And after we add our grass, we can come back and further adjust these values. We might as well just add a few more colors here. We might try to bring in a little bit of yellow maybe, and let's add another maybe darker brown color somewhere, and just overall try to have some variation in our noise. We can maybe do something like this. I might want to go to the fractal here and increase the roughness even more by increasing this diminish value, and this is looking pretty alright for the base color at least. And in the case for our ground, we can also add some normal map information, but it's worth doing a displacement in this case. So we can use another fractal noise pattern for this. We can go ahead and grab this entire setup with our position and multiply here. Let's copy all of these nodes and paste them over here. And I can go ahead and just plug this directly inside the displacement. And by default, this will be super big in terms of scale. So let's go ahead and drop the scale down all the way to maybe 0.1. And we can kind of see the results that we get. So this is maybe too much roughness for our noise pattern. We can drop down the diminished value, so now it's actually starting to look a lot better. We can maybe keep something like 0.65, should be alright, and for the most part I'm pretty happy with this ground. Now here, to get a really good texture, you would have to layer a lot of these noises and patterns together. You can, for example, just copy this entire setup maybe from the multiply. So I can duplicate these nodes and I can do an add over here, and for this multiply, if I set this to a low value like 0.05 and do an add with a second layer of noise, let's give this a second. So now we should have more overall contrast. I can also increase the values here, so if I set this second noise to maybe an amplitude of 3, we should see a lot more displacement overall in our ground. And maybe actually, since we've done all of this, I will keep the second layer here. I might want to scale this down even more. We can do something like 0.02, and we can see directly in our viewport how our ground changes. But let's actually go ahead and get rid of this second layer. This is just to give you an idea that the more elements you layer, the better texture you will have generally. And for now, I'm happy with the ground and our river. And now we can go ahead and scatter some grass. We can now start working on the grass, and for the grass we are going to create this directly in our stage context. So in Solaris we can drop down a SOP create from here. Let's place this from the start in the right path, so we will do /env ground, and we are going to do a grass group, and we can plug this in our merge, and let's see how our chain will look like. We don't have any geometry inside, so this will not update. Let's go ahead, and if I step inside, we can create just one simple blade of grass by using curves. So let's drop down a line and we can frame in on this, and let's do a resample from here, and this will give us a few points. Now we will probably need to scale this down. Let's set the length to maybe something like 0.2, and let's go to the resample and maybe decrease the length, so we have, let's try to go for maybe 5 points. From here we can do a bend, and let's set the capture direction here to 0, 1 and 0, and the capture length should be the length of our curve. So I will copy this parameter and let's paste relative references, and if I press enter we can grab our bend, and we just want to bend this slightly in either direction. This will be fine because we are going to change the orientation per individual instance. So we will use just simple curves that we are going to scatter onto our surface, and we are going to bring this at the Solaris level as a single curve object. So if I go up, let's go ahead and disable the display for our lights, and we have a problem here. We can no longer see our ground. This is probably because we are using transparent textures. If you right click on the material properties, you can change this to matte cap, and sometimes this might work, or maybe we can get rid of transparency. Let's just turn off the material display for now. So if I zoom out, we now see our ground. So for some reason the transparent material kind of messed up our viewport, but we shouldn't have to worry because in our rendered view we can still see our ground properly. So we will disable this material for now. So we have the SOP create here. Let's just rename this one to grass. So if we focus on our single blade of grass, we can see that this is brought over in Solaris. We have this displayed as sort of like a 2D texture that's mapped to the direction of our camera. But when we do a render on this, we are actually rendering it as a tube. And the width of this tube will be controlled through a p-scale attribute. So if I step back inside, we can go to the resample here and we can add a curve view attribute, which is an attribute that goes from 0 to 1 across the entire length of our curve. So now we can do an attribute VOP, and I will rename this one to, let's do set p-scale. I'll step inside. Let's bring in our curve view attribute with a bind node, and we are going to do a ramp parameter here. Let's set this to a spline ramp. Let's also do a multiply to have a global control, and I will promote the second value here to, let's do p-scale global, and from here we can do a bind export to our p-scale attribute. So we can go up, and I will reset the ramp. Let's give this maybe a p-scale value of 0.1. And again, it's always worth setting down some output nodes when we are working with the SOP create tool. So if I go up, we can see this is the result, and we can pin the viewport to the top level. Let's step back in, and we probably have to reverse the ramp. Let's also set the global p-scale to something a lot lower. And like I said, we will reverse this ramp. So now if I do a test render, we see this is the result. I might want to add another point here to maybe thicken up the blade of grass overall and just change this, have only the tip be tapered like this. And I will drop down the p-scale global here even more to maybe 0.01. So this will be our blade of grass, and let's create our scatter now on our ground geometry so we can copy this blade of grass onto those points. So we're going to need our ground geometry. Let's head over back to the geo level, and inside our geoground we can also unpin the viewport. Inside our geoground we will grab this out geoground. Let's go back in our SOP create and let's do an object merge and paste the path over here. So we have our ground geometry. Now we only need to scatter points in the regions where our camera can actually see. So for this we are going to use a very simple HDA that I build, that I use in all of my courses. Let's drop down the camera, the Frustum Cam HDA, and this will be provided with the project download. So here we can specify our camera, and we can bring this directly from the SOP level. Let's hit accept, and if we look at this, it's going to trace a trail of our camera as it's animated through the scene. So if I scale this up on the Z direction, we can see this geometry that it creates. So here we are going to set the end to be 120, which is the end of our animation in this case. And we can also increase the iterations if we want. We can see this kind of takes a snapshot of our camera frustum as it moves through animations. So this should cover the entire area that we are seeing through the camera. Let's also increase the size on the Y and X here to maybe 1.2. And we can use this to delete parts of our ground that we don't want. So we'll go to the object merge. Let's create a group. We'll set this to points. We'll place the camera, or rather the Frustum camera, as the second input. Let's disable the base group and enable keep in bounding regions. And here we can select bounding object, and we will have to push this all the way back. So let's go to our Frustum cam and increase the Z value over here. Maybe we can do something like this. We don't really need this to reach all the way back as far as our grass is concerned, at least. And maybe we can just pull this back even more to something like this. And now we'll do a blast, and let's select this group that we created. Let's delete non-selected. And if we look through our camera, we should see all of the geometry that we need. We can see over here on the edges that we get rid of this geometry. So now we can use this to scatter our points. Let's first create a simple noise to help us in our scatter. So let's do an attribute VOP. We'll name this one set density, and let's step inside, and we can use a turbulent noise. We can just plug this in our CD to preview it, and maybe we can increase or rather decrease the frequency here. We kind of want to scatter the grass in patches like this. We can also increase the roughness slightly, and maybe we can increase the attenuation as well, so this kind of increases the contrast. Now we will do a bind export and export this to an attribute called density. Let's place this here and we can get rid of the CD connection. Let's go up and let's drop down a scatter. We'll set the density attribute. We can see that by default this will look at our density. Let's disable relax iterations and let's just start to scatter maybe 100,000 points, and we will also want to disable the max point limit. So this is what we currently have. Now we also don't want any grass existing in our river here, so after this blast node we can also call everything that's below maybe level 0 over here. So if I simply drop down a clip node and set the direction here to 0, 1 and 0, we can determine where we want to delete this geometry. So maybe something like this will be fine. If we go back to our scatter, we can use these as our points now. So let's grab our blade. Let's actually get rid of this output connection for now. We will drop this single blade inside a copy to points, and let's use our scatter as the template points. And now we have this result. On our scatter, we can add some attributes that will help us with the distribution and everything. But first, let's also add some normals on these points based on our geometry. So after our set density here with the geometry, we can drop down a normal SOP and let's set this to points. So now we have all of these normals and our scatter should also inherit the normals. And from here we can do a scatter and align, and I will set the mode here to add attributes to existing point clouds, and I will place the scatter in the second input. So now I can use this node to just set attributes on the existing points. So I will drop this inside the copy to points, and now if I look at the result, I can go to the scatter and align, and I can increase the minimum and maximum radius for our scale, and I can maybe drop this down a bit, and in our rotation here I can increase this max random cone angle. Maybe we'll do something like 27, and now for our max angle for this rotation around normal, we'll increase this all the way up to 360. And with this, we can create a very simple basic field of grass. Now, we can get a little bit more fancy. We can do a vellum simulation to have actual wind that's affecting our curves and achieve some really great results. But I want to keep this as simple as possible, and I will just bring this geometry as one single curve object into Solaris. So from here, if I place this copy to points inside the output, if I go up, we can see this here, and we can also see this updated with the width on our grass. So this is again using the p-scale attribute that we set up on our curves, and we can also do a quick test render to see how this will look with Karma CPU. In this case, we can switch this back to XPU, and we can also preview this from our out node over here. Let's look through our camera and let's do a quick test render. We can see that this is loading really fast, and if I look inside the grass group over here, we have just this single object which is going to be a curve primitive type. This is looking pretty good so far. We can maybe make our blades a little bit longer. Let's pin the viewport here. Let's go back inside and let's go to our scatter and align and increase the uniform scale maybe slightly, and try to have more of a variance between the size here. Let's also go ahead and scatter a lot more points. Maybe we can let's try 500,000, and now this is looking more like an actual field of grass. And with our noise pattern, we can see that the grass is distributed in sort of like this patch mode over here, so this is really cool. We can also maybe call our geometry at a different height for our river. So in this clip node, maybe I can bring the distance up so we don't have this grass this close to our river. Let's set this to 0. We know the river is right on the ground, so maybe we'll just keep this distance at 0. So now our grass will be called right where the river starts. We can be a lot more fancy with our scattering and our attributes, but again, this is just a demonstration, so I'm not going to spend too much time adjusting all of these values. We can also see that when we turn off our material in the viewport, so if I stop the rendering, I can turn back on our materials, and this will bug out our ground for some reason, but this also affects our karma render as well. So now when I turn back on my material, this change will show here as well, so we can see with and without our materials. And speaking of materials, let's create one for our grass, and we can base this on a hair material. So let's go up and let's go to our sub create here for the grass. We'll drop down another material library. Let's step inside, create a karma material builder, and we can rename this one grass. And we'll dive inside and get rid of our standard surface. In fact, we can get rid of all of these nodes over here, and we'll drop down a karma hair. And let's plug the surface in our first output here on our material outputs. Let's leave this as it is and assign it first to our geometry. So let's autofill materials, get rid of the material path, and we'll place this inside EMV and inside our ground group. Let's assign to geometry, and we can just drag our grass inside this geometry path. And we can see our scene updated. So if we do another test render, we already have this very cool material. So this karma hair material provides us with a lot of options that we can see with just the default settings. We have some really cool results. So we get a lot of stuff for free as far as I can tell. We can set this base color here. We can choose maybe something more of a green, and this melanin will control how our color is sort of propagated through our grass. Maybe this is a little bit too much. We can get rid of a little bit of this. Let's maybe just lower both of the melanin and the redness. We can increase this melanin randomize, and more importantly, this is a pretty cool result, and this would work maybe for some sort of motion graphics kind of effect. But if we want to get more realistic, we will go to the diffuse here and also combine this. If we set this to 1, this will give us more of a standard surface material. Let's also set this one to maybe something like green, like this. And what I want to do here is combine the standard version with the hair version, so I can set this to somewhere in between, and maybe I'll just increase the diffuse here to 0.7. We'll take care of the color in a bit, so I'm not too concerned about changing the color for now. Finally, for specular, we can also maybe increase the roughness. So in the case for grass, I don't think we have such a low roughness. And obviously you can go by feel as well, but we end up with something like this. Now it would be cool to randomize the color per individual strand. So what we can do here is assign an ID attribute for each individual copy and use this ID to create a color that's different per individual strand. So let's stop the render for now. Let's go up and back in our sub create. In order to have this ID, we can add this to our scatter points, and then our curve will inherit this ID. Let's go ahead and unpin the viewport. So what we want to do is create, let's do this with an attribute wrangle. We'll say that at ID will be our PT num. So now when this ID will get carried over to our copy to points, if I were to create a visualizer for the ID, we can see now that each individual strand has a different color. So now we can use this ID. Let's go ahead and turn off the visualizer. Let's go up. And back in our material over here, in order to import this ID attribute, we can use a primvar reader. So we will place this down. And even though we set up the ID as a float value at the sub level, this ID is something that's internally recognized by USD, and it will be brought over in Solaris as an integer. And we can verify this if I were to select this curve primitive over here in our property information. We can scroll down and we can see we have a few attributes here. So we actually also imported our curve view attribute, and this is a float. We also inherited with our points the density. So we can see that we brought all of these attributes here, but more specifically, we need this ID here. And by default, this is again one of those attributes that changes when we go over in Solaris. And this is now an integer attribute. So here for the signature, we have to set this one to int. And for the var name, this will be ID. So if I were to use this as a seed inside a random color, let's drop down an MTLX. Let's actually use MTLX random float, which which will give us a value that goes from 0 to 1. If I place this inside our base color, let's take a look and see what we get. And we actually have to place this in our diffuse color as well, because we are blending between these two values. We can see that now each individual blade will have a color that's from black to white. Now we can't really see this that much over here. Let's pause the render, and what I want to do with this float value is actually filter this through a ramp. So let's drop down a karma ramp constant. And now we can select our colors. So let's say that we want our darkest colors to be maybe a dark green and our lightest color to be maybe a bright kind of yellowish green. Let's do something like this, and we can adjust as we render. So if I do a render now, I'm not sure how noticeable this is. Let's maybe just go to our karma hair here and set this diffuse to 1. So we can just focus on the diffuse color. And maybe sometimes when you are bringing in attributes, you have to restart the render. So let's do this. Let's maybe check if I make this blue instead. We can kind of see this. I think we can make this one red just to make sure that this is working. So we can kind of see some of these are blue and some of these are red. So this is definitely working. We maybe just need to increase the difference in this color. So we'll use a saturated green and maybe something like an actual yellow here. So now we are starting to slowly introduce some variants. Let's maybe add another handle over here, and let's maybe also add some darker blades here and maybe spread these a little bit. So now we are starting to kind of get some variants. Maybe let's move this, spread these out a little bit like so. And this is pretty cool. And earlier I showed you that you can preview just the result of a node. If I were to plug this inside an unlit shader, I can preview just the color without any specular and all of that stuff. But you can also, if I were to grab this node, I can press S and this will append the visualizer over here and we have the same result. The only problem with this is that whatever node you want to preview has to be passed through a shader. So we can see that this node is connected to our shader, which is connected to the output. And this is the only way this visualize works. So I can get rid of this, and for example I can just visualize now the result of this random float, so we can see our black and white values. So this is also sometimes kind of helpful for you to troubleshoot your materials. Let's go back to our karma hair and let's set back the diffuse. Let's introduce more of that melanin business from our color tab, and I think this is starting to look actually pretty alright. We can look through our camera and I'm really starting to like this result. Let's also check our final scene graph, and everything seems to be working just fine. And now we can start working on our trees. We can now focus on our trees. So for our trees, we will need a more specialized treatment, and we can also explore more of the component builder. So let's go ahead and we can place the component builder pretty much anywhere for now. Let's drop down the component builder. So this will build our entire chain. And right away, I will rename this component geometry here. Let's do something like tree, and the component output, let's just export this to a USD asset that's going to be called tree.usd. And we can set the display flag on this, and let's start by building our tree geometry. So we will step inside the component geometry, and here we will focus on our high resolution mesh. So our render mesh, which will go in the first output here. And we are going to use the tree lab tools, which are pretty good, but if you already have a tree asset, maybe from SpeedTree or any other library, you can just bring that geometry in. But to keep things 100% in Houdini, we can use the lab tools. So let's start with a trunk generator. So labs tree trunk generator. Let's take a look. And we can frame in on this with F, and right away I will do a Tommy geometry and place this on the side and template this with W, maybe translate this so it's right next to our tree. And maybe I want this tree to be a little bit larger on our base, so we will go to the length here in our general tab. Let's maybe set this to 15. And this should be fine. Now I'm going to create a very simple tree, so I'm not going to spend a lot of time really adjusting all of these settings. We can see that we really have a lot of options to control how our tree looks, but I'm going to do a very quick setup with a very simple and basic tree. And if you want, you can spend more time to fine tune all of these settings to get a really cool result. Now for our trunk, we probably don't need as much resolution, but this will be fine maybe for just the trunk. Let's go to the noise here, and I also want to introduce some noise as well. Maybe I'll increase or rather decrease the frequency, and let's also go to the secondary tab here as well. Maybe increase the frequency here, or the intensity, and decrease the frequencies. So we just want to break up this completely straight look on our trunk. Let's just increase the intensity slightly. This will be fine. So let's start with our branches. Let's do a 3-branch generator, and I will hold down Shift and press Enter. So we have this connection, but it seems that our second input wasn't connected. So with our first branch generator here, let's turn on randomize amount, and between 5 and 10 should be fine for our first level. Let's maybe just make our branches start higher up our main trunk. So I will go over here to the length, and let's increase, or rather move, this handle on our ramp here, and we can see that we are slowly pushing all of these branches up. And maybe we can decrease, let's also add some length variation. This will be pretty important. Maybe I will increase the overall length. And for the resolution here, I really don't need as much resolution. We can also go to the radius and slightly decrease this overall radius. So I will squeeze in the radius adjust values slightly, maybe something like this. And let's go to the resolution finally over here and just increase these values, so we really don't need as many subdivisions. So I'll reduce some of these divisions, maybe something like this will be fine. And for our first level, I also want to introduce some noise as well. Decrease the frequency in both first and the secondary one, and maybe increase the intensity. So we end up with something like this. Should be fairly good. We can now duplicate this node with Alt. So let's just duplicate what we already set up and reconnect these nodes. And we can see now that our branch generator will automatically latch onto our second level, which is really great. So this is a really fun way of working, to be honest. We'll go to the general tab here. We want to decrease the length of these ones. So let's decrease the length quite a bit, and let's maybe readjust where they start. So we do want these. This will be probably our second level, I believe. So let's readjust where these are placed, and maybe we can also have more branches. Let's do maybe 8 and 16 should be good. We can go ahead and also we might want to decrease the resolution with each level. Let's maybe just increase the resolution and the division sizes here. This should be good. Again, I'm going pretty fast because it's really not the point of this course. Let's do one more level, or I believe we have to do 2 more levels, but let's just connect our level 3 over here. And again, I can decrease the resolution with each level. And I believe on this level we can start adding our leaves. So let's maybe do this. We can drop down a 3-leaf generator. So let's place this here. Let's plug our first and second input to our branches. And if we go to the leaf generator, this will give us cards by default. So if you have a texture for leaves, so for example, Megascans has a lot of leaf textures that also have the alpha images for transparency. Now, in the case for Karma, we don't really have, or at least with Material X, we don't really have a good solution for transparency when it comes to 0 and 1 values. So for example, in Redshift, we have a RS sprite node that will allow us to create a very simple cutout using the transparency maps. And it's a lot more efficient when it comes to textures with transparency. So as far as I know, we don't have that yet with the Material X builder, but we might have a solution in the future. But all of this is to say that for now, because we want to also keep everything in Houdini without using any external textures, let's go ahead and just model a simple leaf mesh ourselves and copy that onto our branches instead of these planes. So for our leaf mesh, let's go ahead and just drop down a grid over here to the side, and let's make this really small. Let's do something like 0.1 and 0.1, and we can compare this with our Tommy geometry. Probably we need something a bit bigger, so let's do 0.3 and 0.3 on both axes, and let's actually untemplate the Tommy geometry. We will have to align this so it's on the Z axis with the pivot at world origin. So let's do a match size from here, and let's set the justify Y to min. And now from here we can do a linear taper. Let's add this. Let's go to our taper, press enter. I will press N to fit our capture. Then inside the taper tab over here we will enable ramp, and we can sculpt the shape of our leaf. So let's add 1 point at the end here, completely tapered, and 1 point at the beginning, and we can start to slowly build up a shape that kind of looks like a leaf. Maybe let's set this interpolation to B-spline, and I will reduce the overall length. Let's maybe zoom in on this. So I think this is already starting to look kind of like a leaf. Again, we are going to go pretty fast, so this will be fine, and we don't really need as much resolution here. So let's go to our grid, and let's leave the rows maybe at 6 and decrease the columns to 5. So this should be good. And let's also just introduce some bend as well. Let's drop down a bend former. Let's press enter, press N, fit our capture, and maybe let's press B so we can bend it on this other axis, and we will set the capture origin here. Let's set this to 0 so it starts in the center of our leaf, and maybe I will reduce the capture length slightly. And now we can turn on the option here to deform in both directions, and we can bend this leaf a little bit like so. And let's do one more bend and also bend this. Let's do N, and we can bend this maybe downwards like this. And now we can also compensate for this rotation with a transform, and let's just rotate this slightly up so it's more flat on the ground. And now we can use this as our leaf geometry, so we can plug this in our third input, and now this will be copied onto our branches and replace the plane that we had previously. By default these will be pretty small, so let's go ahead and increase the uniform scale here. Let's set this to 1 and see what we get. Alright, so this is starting to look pretty cool. I might want to... This is probably about the right size. Let's also increase the uniform scale variation. Let's try something like... Let's do 0.5, and maybe we can just increase the uniform scale slightly to maybe 1.2. So we have overall a bit more coverage, but I think this is looking pretty fine. We can come back and readjust some of these values if necessary. This can be our simple tree. We no longer need Tommy over here. Let's make some room, and let's prepare this asset for Solaris. Now if I go to the information here, we have quite a few attributes and a bunch of groups that we really shouldn't bring over to Solaris. So in this case, since I want to assign one material for the leaf geometry and one material for the trunk and branches, we are just going to separate these two meshes. So let's go ahead and let's start with a split node, and there should be a group that the tree tools already provide us with. So if we go to leaf, we can select just the leaf group over here. So our first output here, let's do a null, and this will be our leaf geo. And now our second output should be all of the branches combined. So we can name this one, let's just do trunk geo, even though we have the branches as well. This should be fine. And now from here we can grab both of these, and let's merge them back together, and we can assign a different name for both of these so they are separate objects inside of Solaris. So let's drop down a name SOP, and let's rename this one to leaf. Let's do leaf geo. And I will copy this over to the trunk geo as well, and let's rename this one to trunk geo. And from here, let's drop down an attribute delete, and let's delete non-selected, so this will get rid of all of the attributes. And now we can decide on the attributes that we want to keep. So we are not going to need any of the point attributes. For the vertex, we will need our texture, so our UV coordinates, and this will be mainly for our trunk geometry. And for the primitive attributes, we will need to keep our name that we just created, so these names over here. And let's also do another group delete node as well, and we will get rid of all of our groups. So now our geometry should be nice and clean. We just have our UV and our name attribute. Let's plug this as our first output, which will be our render mesh. And if we go up, we can go to our component output, and let's check our scene graph first. So we have this tree asset, we have our geo, and inside here we have our leaf geo and our trunk geo. So this is looking good, and now we can work on creating a proxy geometry that we will preview in our viewport. So we can base this again on the geometry that we already have. So let's go back in our component geometry, and for our proxy geometry we can just run a simple poly reduce from our last node over here and maybe keep 10% of our geometry. The problem here is, and let me show you, let's do a poly reduce, and let's set the percentage to keep here. Let's do 10% and see what results we get. So definitely not bad. This can definitely work as the proxy geometry. Maybe around 100,000 points is still too much for a proxy geo. So if I were to set this percentage to keep here, let's maybe try value of 3. We end up with around 18,000 primitives, which is more on the lines of what I would expect from a proxy geometry, but we see that we kind of lose a lot of our leaves, and this is because our poly reduce is almost completely decimating our leaf geometry. So if I compare these two results, we can kind of see that we are losing the leaf geometry. Now, we don't really have to just use the poly reduce. The proxy geometry can be any geometry that we plug in here. So if I were to drop down a cube and set this as the proxy geometry, now if I go up, we can see that in our viewport, we are going to see only this cube. And when we do our render, we are actually bringing in the render geometry. So knowing this, we can go inside and we can create more of a custom geometry for the proxy. We can also use these meshes that we have separated over here. So the poly reduce will work pretty much all right for our trunks, and maybe we don't actually need to keep all of our levels. So let's do a blast node first, and let's keep maybe level 0, or actually we can select level 0, which is this one, and we can delete non-selected to keep only our main trunk. And now I can select what other levels I want to keep. So maybe I want to keep level 1 as well, and maybe level 2, so we don't really need to bring all of the geometry. Let's just keep these 3 levels, and from here let's do another poly reduce, and let's reduce this to maybe 10%, or maybe I can increase this, maybe do 25, and we end up with around 5,000 primitives. So this is looking good. And for our leaves, I would like to mesh this entire geometry together somehow, and we can use an SDF to turn this geometry into a volume and then convert it back to another mesh geometry and kind of have all of our leaves sort of mushed up and combined into a single solid geometry. Because we don't have thickness on our leaves, they are just simple planes, we can't really use an SDF. So one solution for this would be to add some thickness to our leaves with a poly extrude, and that might be a little bit of a costly operation. So instead, what I'm going to do is turn all of these leaves into points, then copy simple spheres onto those points and use the spheres to turn into a volume. So to extract the points for each of these leaves, we will need an identifier attribute for each individual leaf, and we can use a connectivity SOP for this. So when I drop this down, we will assign a class attribute, which is an integer, across all of our leaves based on their connectivity. So this is sort of like the ID attribute in a particle simulation. And from this connectivity now, we can drag this over to the side and we can do an extract centroid, and we will run this over pieces. The piece attribute should be our class, and this attribute is actually stored on the point level. So let's set the piece elements to point, and here we should find our class attribute. So now we have a point in the center of all of our meshes. If I were to template this, we can see our points over here. We can turn on the size of our points. Let's increase this to 10. All right, so here we have it. And now we can use these points. Let's go ahead and let's maybe arrange these nodes slightly. So now with our points, we can turn all of these into an SDF. So let's do VDB from particles. I will plug this down before connecting it, and I will right away set the point radius scale a lot lower and reduce the minimum radius to 0. And let's plug this and see what we get. So already this is looking pretty good. From here we do a VDB convert, and we can set this to polygons. We end up with this mesh. Now this is still pretty high resolution, so let's go to our VDB from particles and increase the voxel size by quite a bit, and I can increase the point radius scale as well. So we end up with something like this. I might want to just increase the voxel size and play around with the voxel size and radius scale. In our convert VDB, we can also play around with the adaptivity to slightly optimize this mesh, and we can also play around with the ISO value here as well. And I'm looking at the count here, so 30,000 primitives should be fairly good. We can still run a poly reduce after this and start to reduce some of these values. So now we have around 18,000 primitives, so it's looking pretty good. If we were to bring these two together, let's drop down a merge between them. So here we have our poly reduced trunk, and here we have our converted leaf mesh. If we merge these together, we end up with around 23,000 primitives, and we can plug this in our proxy output now, and we can also copy our attribute delete and group delete nodes as well, because we will want our proxy geometry to be clean as well, so we don't bring any unnecessary attributes in Solaris. So we will plug this in our proxy, and if I were to compare the render geometry with our proxy geometry, we have a fairly good representation, I would say. I might want to play around more with the VDB from particles, maybe reduce the point radius scale here and the voxel size, just slightly try to increase this quality so we have a more accurate representation. But for the most part, I can say that this is giving us a pretty good estimation on our render mesh. So while we are working in the viewport in Solaris, we will be able to judge more fairly where our placements should be for the trees, and we will overall have a very smooth and optimized experience when working in the viewport. We can also create a seam proxy, but I know in this case I will just place these without using physics, so I'm not gonna worry about the seam proxy output for now. So if I go up, let's see what we have. We have our asset. We have to actually select our component output here. So we have our tree, we have our geo group with our proxy geometry and our render geometry. So in our viewport, we will see this, and when we do our render, we will see our high quality mesh. And now from here, we can probably start working on the materials. So we can start with our leaf, and let's dive inside the material library. We will create a Karma material builder, and we can name this one, let's do tree leaves, and let's just copy this one and do tree, and we'll do trunk. So in our tree leaves, let's go ahead and start with a basic color adjustment. So we will make this green. Let's go up, and in our tree trunk, let's set the color here to maybe something like a brown, and this will be automatically assigned, as we can see, but we are going to change the assignments in a second. Let's maybe drop down the value and saturation, and something like this will be fine. And also in the specular, I will just turn up the roughness because I know we will need this later. So we can go up and let's create our assignments now. In our component material, we will do our first assignment here. We'll grab our tree trunk, drag this in the material path, and inside the geo, we can assign this both to our proxy and our render mesh. So let's drop our trunk geo from the proxy, and we can also add our render geometry as well. So here we can just copy this path, press space, and paste our path, and instead of the proxy group here, we will set this to render. So we can see our material in the viewport, and if I press Shift R, we should see this in the render as well, and we do. And we will do the same for our leaf material. So let's grab our trunk leaves, place this in the material path, and I will grab, we can see actually in our proxy, we have a surface mesh, and this is because we got rid of the name of our leaf mesh. So let's go ahead and make sure that we keep things consistent. So let's dive back inside, and we are going to grab the name that we set up on our leaf geometry. Let's do Ctrl C, and we will copy this on our leaf mesh over here after we do all of our adjustments. So this is set to leaf geo, and now this should reflect in our scene graph. We can see in the proxy we have leaf geo as well. So it's very important to stay organized. So back to our component material, let's drop our leaf geo in the primitives path. Again, I'm going to copy this path, paste this over here, and replace the proxy with render. And again, we can see in the viewport our material for the leaf works, and if I do a render, this works as well. So from here we can start adjusting these materials. We can also do a sky. So let's drop down a Karma Physical Sky from our component output. I will increase the exposure to a value of 2, and we can do our look depth with some actual lights in the scene. So for our leaves, I would like to be able to randomize the color per individual leaf, similar to how we did this with the grass material. So inside the grass material, we used a primvar to read an attribute on the geometry that's called ID. And for the leaves, we already have an attribute that we set up that's going to be an individual identifier per each individual leaf that's called class. So this is what we created with our connectivity node over here. Again, if I were to go to the result here and I were to create a visualizer for this class attribute, let's go ahead and turn this on. We can see we can generate a random color or a random value per individual leaf. The problem here is that when we go to our attribute delete, we get rid of this class attribute. So in our points attributes here, let's also choose to keep our class attribute. And for our proxy geometry, this won't matter that much because we don't really have any individual leaves that we can take care of. So with that being said, let's go up and back in our material, let's step inside our 3 leaves and let's bring in our class attribute with a primvar reader. This will be an int attribute. The var name should be class. And if I were to generate a random float value from here, let's plug this in our base and in our base color. And if we do a render now, we can see that this will override or error out as far as the proxy geometry is concerned. But when we go in our render view, we should see all of our leaves have this random color from black to white. So we can map this to our own color. So let's do a karma ramp constant, and we can map our black color to a dark green, and let's map the white color to something like a brighter more yellowish green. So maybe something like this. We just want some variation per individual leaf. So we are off to a good start. Let's maybe just introduce one more handle over here, and let's try to just get a little bit of some extra colors here. Maybe have a green that's more desaturated. And I believe this will be fine. And when it comes to creating trees and vegetation in general, it's always worth using subsurface scattering. Now this will increase your render times, so this can get pretty costly to render, but I believe you get a really cool result. So what we can do for our material is go to our subsurface tab, and we can set this all the way to 1, which will mean now that our geometry will absorb this color that we set over here. Now this color, I want to use the same color that we have in our base. So we'll grab the ramp constant and let's plug this in our subsurface and in the subsurface color. Let's actually expand this window. Now by default, the scale of 1 will be way too high. So this is again using real world units, and we know that a leaf doesn't really have a thickness of 1 unit length. So let's drop this all the way down to maybe 0.05. And for the radius, we can also change how much color we want to absorb. And in this case, I want to absorb more of a green kind of colors. So this color will decide how this subsurface color is being scattered through our geometry. So I just want to tint this slightly towards green as well. And finally, I don't want to have full subsurface effect on this geometry, so I will drop this down. Let's maybe use something like 0.6. So this is the result that we get now, and with subsurface scattering we really get more of that luscious kind of green that's usually common with vegetation. And we might want to adjust our sun here for the sky to see this better, and also I will set this to Karma XPU just so we have a faster or a way faster render in this case. And finally I might just want to increase the uniform scale of our leaves. So maybe if I look from the side, I think honestly that we are missing one level of branching here, so we can either increase the size of our mesh to get overall more coverage, or we can add one more level of branch geometry. So let's go ahead and in this case, to keep things simple, let's just increase the size of our leaf. So let's go up and let's go back in our component geometry, and for our leaf generator we will increase the uniform scale here to maybe 1.6. So now if we compare this single leaf to a Tommy geometry, we are going to have something that's pretty massive and not really accurate, but again we are just looking for more coverage. So let's go back and let's go to our render view, and if I were to play around with the sun slightly, let's lower the altitude and turn the sun around. If we zoom in on this, we should be able to see our subsurface effect a lot more, so we can see how this light is getting now absorbed a little bit inside the leaves. So if we go back to our leaf material, if I were to set the subsurface to 0 and completely remove it, we now just have a standard base material with no light absorption. So when we increase this to maybe 0.6, we can see all of these nice gradients forming naturally in our leaves. So this is really cool, and it will probably look even good in our main render. And also let's go in our specular here, and we don't need such a low roughness. Let's increase the roughness to maybe 0. And let's also take a look in our trunk and branch material. So we'll go up and let's step inside our tree trunk, and we can start with some fractal noises. If I drop down an MTLX fractal 3D, we can plug this in our base and in our base color to see the default result. So right away I want to stretch our noise, and earlier I showed you how you can use the world position to stretch the noise, but we can also use, in this case, since we have UVs, we can use our texture coordinates on which we can map this noise. So in this case we will drop down a MTLX texture coordinates. Let's plug this in our position, and now if I do an MTLX multiply in between, we can stretch our noise on either of the texture's directions. So if I increase the input to values here, let's try the first value, let's set this to 5, and the second value, let's set this to 3. Let's go ahead and start to increase this and stretch this until we get something that starts to look kind of like a bark texture. Maybe use a value of 3 or 4 over here, maybe 4 will be fine. And we will want to normalize this noise as well. Let's do a remap over here and set the in low to -1. We can also introduce more roughness in our fractal 3D. So we'll increase the octaves to 10 and increase the diminished value here. Let's maybe try something like 0.86, should be good. And now we can map these colors. Let's do a ramp constant, and we can use something like a dark desaturated brown, and for our light color we will use again a desaturated darker brown. So already I'm starting to like this result. Maybe increase the saturation slightly and decrease the value. This should be good, and we can again use the same noise texture as our normals. So from our fractal 3D here, let's maybe go ahead and copy these nodes so we can have more control if we need it. From our fractal 3D, we will have to do a height to normal conversion, and then we can plug this inside a normal map, and this one we can plug inside our geometry and inside the normal slot, and let's see what we get. And by default, again, the height to normal value will be too high here. Let's set this to 0.1 to start with. Maybe we need to go even lower. Let's set this to 0.05, maybe even 0.03. And this roughness on the normal might be a little bit too much. We can go to the fractal here and let's get rid of some of these octaves. So I think this is looking slightly better. We can also increase our scale. Maybe we can set our second value here to 3 and maybe decrease the first value. So we end up with something like this, and I believe this is looking pretty good. I think this is passable as a simple bark texture. Obviously, again, here you can layer a bunch of these fractal noises to get a more complex and detailed look. And also you can use one of these textures as a displacement as well, and you will get an even better result. But in the case for our trees, I will not use displacements. And in case that you want to use displacement, it's very easy to set up. We could essentially just plug this directly inside our displacement and then just lower the scale. We can do maybe like 0.1, and it would just be a matter of playing around with the actual noise pattern. So I'll go ahead and get rid of this connection and just use the normal bump in this case. So at this point, I believe we have most of the elements that we need. We could go ahead and save this out as it is, but first we would like to create some procedural variations of our tree geometry. So now we can add some geometry variants for our tree asset, and we can drop down a component geometry variants, and we will plug this here similarly to how I showed you in the earlier lessons. By default with this node, we can simply add more component geometry nodes, and we can plug them inside our variants input node here, and we can cycle through these variants. So this is the default way this will work, and we can see the source mode here is set to inputs, but we have another mode which is going to be this number option here. When we are activating this mode will allow us to use a seed value inside our component geometry to procedurally generate multiple different variants. So let me show you how this works. Let's maybe set the number of variants here to 2, and let's step back inside, and for now let's ignore our tree geometry and just focus on some simple geometry. Let's maybe do a platonic solids, and let's say that this will be our asset, and we can get rid of our proxy for now. So if I go up, we will only have our platonic over here. So again, with this component geometry node here activated and set to the source mode number, I can step inside and I can use that seed value to generate multiple different versions. Let's maybe set the display to the platonic, and I will duplicate this platonic, and let's set this maybe to octahedron, and let's do a switch between these two meshes, and in our switch node I can insert that seed. So that seed will simply grab the value of our current variant, and I think these numbers start from 0, and our seed value will be this expression at geo variant index, all in capital letters. So make sure that this is spelled in this way, at geo variant index. When we place this here, this will evaluate by default at 0. But now when I go up and I go to my Karma Physical Sky, or actually let's just go to our component output here where it says stream, we have our geo with just one shape. And now if we drop down a set variant from here, in our geo set, we will have 2 variants, and now we can choose from our regular platonic solid and our second version, which will be this octahedron version. And we can see the name here will grab the name of our node. So here, because we are going to work on a tree variant, let's just set this to tree variant. We can see the variant name here will grab $OS, which will be this name that we set on our node, and then the index value, which will be the number of a variant. So again, if we go to the set variant here, let's remove this variant name, and now we can cycle through tree variant 0 and tree variant 1. And if I wanted to have another variant, I can go inside. Let's duplicate the platonic. Let's set this to maybe a soccer ball. And now if I go up, we have to set the component geometry variants. We have to update this to have 3 variants. And now when we go to the set variant, we will have variant 0, 1, and 2. And our variant 2 will be this soccer ball. So this is how we can use this geo variant index function that we set up over here. This will give us again the value of our current variant. So if we have 3 variants, this value here here will evaluate to either 0, 1 or 2. And if we have 5 variants, we'll go from 0 all the way to 4. So what we can do with this value is randomize certain things in our chain here for our tree in order to get a different seed and have random placements on our branches for each of these levels. So we will go ahead and get rid of the platonic business here. Let's place the group delete back in our output and we can go all the way back. We can start, maybe we can randomize the noise for our main trunk. We can go to the noise shape and here we have an offset that we can use as a value to randomize our variants. So here we will just do geo variant index. So now our first variant will be 0, our second variant will have an offset value of 1 and so forth. If we want to make sure that these values are different enough, we can probably multiply this value, so we can do times 3. So now we will go from 0 to 3 to 6 to 9. So this will make sure that our noise is has a different pattern for each variant. We can copy this also to our secondary noise. Let's place this here and this should be alright for our tree trunk. More importantly will be our tree branch generators, and here luckily we have this option that we can just change here. So if we change the value for the randomize, this will automatically give us a new seed for the placement of our branches, and also this will randomize our generation here because we set displacement mode here to randomize node amount. So here we will just do geo variant index and I will just copy this expression and I will paste this on our second level, and let's also place this as our third level. And in between lessons I forgot to mention this, but I added a fourth level just to have overall a bit more leaves and have more of a filled kind of tree look. So all I did was copy our third level here and use this as our fourth level, and everything else stayed the same. So also in this randomize here we can drop down another geo variant index. So now if I go up, we are probably going to need to let this run for a few minutes to evaluate all of our variants, but in fact I will cancel this for now, and in our component variants let's set this to, let's maybe have 6 variants. So I'll set this to 6 and now I will let this entire chain cook and evaluate to our final asset. So I will give this a minute and pause the video. So after this evaluates, we can go to our component output, and in our set variant we will have 6 variants, so we can cycle through. We can see this is variant 0, 1, 2 and so forth, and in fact we can now do an explore variants after our tree. Let's plug this over here and let's set this to explore variants and increase this spacing. Maybe we'll need to set this to a high value. Let's try 15. And we can see all of our variants nicely lined up, and all of these have a different geometry, so this is perfect. And our material will update for all of these as well, and we'll explore the material variation in a second and show you what options we have when it comes to randomizing materials per instance. And if we go to our Karma Physical Sky, we can see our viewport display is pretty fast, and if we do a test render for now, we can give this a second and we can see we have a problem with the materials not showing, and this is we have an error over here with the component material not being able to find some of these primitives, and this is probably because we forgot to also plug in our proxy geometry back as well. So unfortunately we'll have to go up, and this will force us to reevaluate our nodes. So again, I will pause the video while this happens. So now that this has been reevaluated with the correct material assignments with our proxy geometry, we no longer have this error and we can see our meshes. So this is very fine, a very fast method in which you can generate a ton of variations. We can see that all of these look rather different with kind of minimal effort, and you can only imagine if we were to set up a more complex chain at the sub level over here, or if we were to simply add this geo variant index to more of these tabs in our branches, we can really get a lot of variations in our geometry. So this is a super useful feature in Solaris and the component builder. Now let's say that we want to add some material variation as as well. Earlier I showed you how you can create the material variants directly inside the component builder. So for example, I can have tree trunk here version 2, and then we can go up and assign it with a new component material. So this will be stored in the MTL variant set, but we have a better solution in this case. So if I were to go back inside our material library, let's say that I just want to randomize our leaf material. Let's step inside. From the karma ramp constant here, I will drop down a color correct node, and let's rewire these nodes. Let's grab both of these wires and link them with the color correct, and our ramp should be inside our first input here in this MTLX color correct. So if I do a render now, we can very easily create some variations if we simply adjust our hue values here. So we can see as I start to increase the hue values, this overall color will be more blue, and more specifically we want to go in the opposite direction, so the negative values here, and we can see how easily we can create sort of like this autumn kind of orangey vibe. So this hue I would like to be able to randomize per individual copy of our elements. So I'll set this back to 0. And the way that we can do this is with a USD primvar reader. So let's go ahead and we'll drop down a USD primvar reader. Now this node here we used to read certain attributes that are stored on the geometry, but we can also use this to create our own attributes. So if that attribute doesn't already exist on the geometry, we are going to create this. So we want to control our hue over here, and this is a float value. So we'll leave the signature to float, and I will give this var name. I will set this to hue. Fallback value should be the default value which we are going to use, and in this case the hue here is set to 0, so we will just leave this fallback value as 0. So I will plug this here, and now if we go up, and now what I can do after the explore variants here, we can actually place this after the karma physical sky as well. We have all of our components placed inside this explore variants group, and inside here we will have the tree, and the tree is split up in all of the geo variants that we have. So from here we can assign a material variation, and we will have to specify the primitives that we want to change. And because our primvar that we created for the material is stored on the leaf geometry, we can do a drop down here until we find our render geometry, and inside here we will have this leaf geo. So if I drag this in the primitive path, we should be able to see in our primvar tab here, we have our class which we are reading from the sub level, and we have this hue that we created. So if I select this for our variant number 1, we can see that as I increase this value, our color changes in the viewport. So this is what we want, and in order to affect all of them, we can do a star symbol to replace the first half of this path. So really we are just looking for our leaf geo over here. So if we go at the end of our path, we have our leaf geo that's stored inside render, that's stored inside this geo, and then from here is where our path will change, because this is component material 1, and we can see that we will have geo3 variant 1 MTL component material. So these are the ones that changes, and this is where the path changes. So we will grab all of this path and replace it with a star symbol. And now this hue change will affect all of our objects that are stored inside this explore variant. So really all of the objects that have somewhere inside them this path geo, render, and leaf geo. And now in order to randomize this per individual object, we can set this primvar here to use snippet instead, and the way that we can set the value, so for example if I want to just change the value directly, I can do value equals, and I can give this a value, so I can do 0.5, and we can see that this will change our hue for all of them. And in order to randomize this per object, we can do a random expression, and the seed will be index. So this index expression here, let's maybe zoom in, this index expression will grab the current object we are iterating on, which will go from 0 to 5 since we have 6 objects. So we can use this random and we can fit this value. So this value goes from 0 to 1, and we'll do a fit 0, 1, and in between parentheses, let's change the hue maybe from -0.2 to a value of +0.2. and we'll end the expression with a semicolon. And now we can see we have a different hue per individual object. So very easily we can control the material this way, and we can add as many primvars as we want. So for example, we can step back inside our tree leaves here. I can just duplicate our primvar reader. Let's say that I want to control the gamma as well. I will change the var name here to gamma. This will be another float value. And for the fallback value, we see that this is by default 1. So we should also set this to 1. Let's plug this in our gamma. And now if I go up, let's go to our material variation. We can do one more primvar. Let's say this plus icon. And here on our second one, we should find our gamma as well. So we can choose the gamma, and again we can randomize this per individual object, and we will check use snippet, and we can copy our expression from above. Let's maybe go ahead and stop the render while we are doing this. So let's copy this expression, bring this down below, and let's say that I want to randomize the gamma from maybe 0.7 to 1.5. So now we should have some of these values, or some of these trees will have more contrast in the color, and some of them will have less contrast. Maybe we can exaggerate this value even more. Let's try 0.5 and 2. So I'm not sure how noticeable this is, but I think that it works. If I turn this primvar off, we can see that these are the default values, and when I turn this back on, we kind of have a little bit of this contrast change per individual element. And maybe our hue adjustment are a little bit too strong, so I'll do from -0.1 to 0.1. So very easily we can generate with just one single asset a lot of trees variation. I could very easily just increase our component geometry variants. I can have 10 different variations, or 100 even, and all of these are stored very nicely in one single tree asset. So if I save to disk from our component output, let's save this. I can bring this in as a reference. Let's copy the path from our location here. I will place this in our file pattern, and with this reference we have this tree, and if I press Shift R we have the material. So this is working, and in fact I would be able to just copy this explore variants with all of these nodes, place them over here to replace this, and with the material variation we can very easily start to generate an entire forest this way. And in fact from here we can go ahead and let's take care of our hero trees. So these will be trees that we are going to hand place in our scene to build up our composition, and we can drop down from over here. So this will be our main chain, and this will be our, let's draw a network box on all of these ones. So this will be our ground with the geometry, grass and water, and I'll drag all of these elements up. Let's start with a stage manager, and with the stage manager we can directly reference our file from disk. So inside the file browser I will go inside my over here, and in our USD this is where our tree is going to be saved. So we have this tree.usd, and I can just drag this in my scene graph. We have this over here, and whenever we do any changes on our component builder for our tree or our materials, I would be able to just simply save to disk and override our file, and this will update in our stage manager as well. So in this way we can keep things very procedural, and now with the stage manager I can merge this in our main chain, and I can start to place some of these assets around. So let's go to our merge, let's go to the stage manager, and with the stage manager active I can start to place around some of these trees. Let's turn this around. Maybe I will hide this window as we are working. I'll press Ctrl 2, and let's press Ctrl 2 one more time so we get this horizontal split. And in this bottom view let's set this to our camera. So now I'm able to place the tree here. Let's maybe also preview our outline for the geometry, and I can go ahead and start to place our trees and see what results we get in the composition. Actually I'll get rid of the outline. So now I can press Ctrl D to create a duplicate. Again, both of these will simply reference our file on disk, and now I can right click, I can go to Geo, and I can actually use a different variant. And if I go to the inspector I can also set this variant over here. So if I select my tree 2 we can set this variant, we can set this over here, or we can right click, go to Geo and set the variant in the viewport direct. So I can very easily start to just populate our scene. And we are going to use the stage manager to place these trees in the foreground. And for the background, we are just going to use an instancer to scatter a bunch of trees and cycle through all of their variants. Let's go ahead, and also on this one, we might change the geo variant. So let's for now place one more tree, and I'm not gonna spend too much time simply placing down trees, but hopefully you get the idea on what the workflow is here. Let's also change the variant here as well. Let's maybe use variant number 4, place this maybe in the back, and I'm looking at this view through our camera here. We can also go to our out scene and we can start to make some test renders as well. So here we have it. We probably can go to the stage manager, press enter, and I can directly change our trees. This might take a second to update, as we can see, so maybe we need to let the Karma XPU engine run for a little bit and we can get more responsive placement. We can see there's quite a bit of lag between updates, so we can definitely work this way. I'll go ahead and let's stop the render, go back to the viewport. Maybe I'll change the geo variant here. Let's maybe use 1. Let's do one more copy. I'll place this somewhere around here, and maybe in between lessons I'll go ahead and reposition these trees so it makes a little bit more sense. I don't want to waste your time just simply placing down trees. But let's say that I'm happy with this placement. So now what we can do with our scene graph, let's go ahead, let's go back to our single display and preview our scene graph. So we have all of our trees placed directly into our scene. If I select this merge, we can see our scene graph, how it looks like. So we will want to probably place all of these trees maybe inside the environment group somewhere. So here we can have another group called trees. Let's go ahead and in our stage manager, we'll do a plus and we will do, let's set this to EMV, which we already have. Let's do another plus here and we can make another new group here called trees. And inside this group, we'll have our hand placed trees. So this will be, let's do hero trees, and we'll grab all of these trees that we copied. Let's place this inside our hero trees. And we are going to later add another group with instance trees. And if we do a render from here, we can also maybe go through the camera. Let's set this to Karma XPU. So here we have our trees. We can always just go back to our stage manager, grab one of these trees, and actually let's make sure that we are grabbing an individual tree. We can place them around, and probably before starting to duplicate these three objects, we should have placed them in the correct path from the beginning and then start to move them around and duplicate, just to ensure that we are not going to lose any of our transforms when we create new parents groups for them. Regardless though, this will still reference our USD file from disk. So if we are going to update this USD asset, this will reflect in our stage managers. So this is really cool because, for example, if I were to go to my materials here, let's go to the Karma Physical Sky and let's do a render. So for example, if I were to go inside the material library and let's say that for the tree leaves here, let's go to the color correct, I can maybe increase the lift just to get a completely different result, or a different enough result. Let's stop the render, and if I were to go over here to the component output and save to disk, this will override what we have. And now if we go to our out scene, we should have this material change updated on all of our trees. So let's start a render. Let's go to Karma XPU, and we can see now that all of our trees have this new material with this lift adjustment. So really powerful way to work everything. Again, we can keep things very procedural and non-destructive. So it's really fun to work this way after you set everything up. I will set the lift back to 0 and I will override our tree asset again. So now one more time, one last time, let's do another render, and now we are going to have our green back. So it's starting to look pretty decent, and now we can go ahead and take care of our scatter trees here in the back. For our trees instance, we will have to create our point geometry first of all. So let's go over here where we have our stage manager for our hero trees, and we'll drop down an instancer. Again, we can plug this, maybe we should plug this after our stage manager. I usually like to keep things separate, so we could also disconnect this and just do a merge with our stage manager, but in this case we can just append this over here and we can straight away rename this one to BG trees. Alright, and for our prototype we are going to use this asset that we build, and we can bring it with a reference node. So we'll drop down a reference and let's see what path we used over here. I'm going to grab this path where we saved out our tree component, and let's go to our file pattern, place this here. Alright, and we can place this as our prototypes. So in our BG trees, this is where we will have to create our point geometry, so we can step inside, and I usually like to start with a simple point until I figure out the prototypes. So let's hit this plus and create one point, and if I go up, if I look at the BG trees, and this is why, and we can see our tree over here. Let's maybe disconnect this from our stage manager for now so we can just focus on our instancer, and we should see if we do a render that everything works, and we can go ahead and let's update the paths here. So we can place this inside the environment and inside trees, and here we'll have instance trees, or maybe we can do, let's do BG trees. Additionally, we could just use the $OS expression, so it will grab whatever name we choose for our instancer and it's going to be placed in our environment. So if I plug back my stage manager, we have our hero trees, and then we have our instancer over here with our background trees. So this path will be fine. Let's go ahead and disconnect this one more time. So in our prototype primitives path, we can see that this evaluates to our tree asset. Now we will want to scatter a different variant of this geometry per point. So for our tree asset over here, let's drop this into an explore variance node, and here we can rename this explore variance. Let's maybe be specific, and we can rename this one to tree variance, and this will update over here, and we can see again this will be highlighted in green, which will mean that it has a composition arc, and we have to flatten this layer in order for our variance to work in the instancer. So after our tree variance, and let's also set the mode here to explore variance and set the spacing to 0, so they're all on top of each other at world origin. Let's drop down a configure layer node, and let's go all the way down and choose here flatten input stage. So this will get rid of our composition arc, and we can use all of these variants as we see over here. And we will also have to update our path for this primitive to reflect our geo3 variant objects. So inside our instancer here, let's go ahead and do slash, we'll use tree variants 3, and here we want to cycle through all of these variants, so we will do our star symbol, and now let's see what we get. We will need to scatter more points. So if I were to replace this add node with a simple grid, let's make this maybe 100 by 100 because our tree asset is really big. So if I go up, we should have now a different variant per individual point, and let's maybe make our rows and columns, let's do 5 by 5, and let's go up. Maybe this is still too much. I will pin the viewport to the top level and step back inside. Let's maybe increase the size even more. Let's do 500 by 500, or actually maybe 200 by 200, right? So we can explore all of our variants now. And judging by our viewport now, we can safely say that each of our points are getting one of our 6 variants that we set up for the trees. So our setup is working, and all we have to do now is actually create our point geometry that we need. So I'll go ahead and get rid of these nodes. Let's go up and let's plug back our instancer into the stage manager. And for our geometry, if I look at the merge result, so we can also preview our ground geometry, and for now maybe I can disable this node. For our point geometry, we are going to create just a simple semicircle geometry in the back over here and scatter some points onto that curve. So let's keep the viewport pinned at the top level. I will re-enable my instancer. Let's go inside and let's drop down a circle and choose the polygon version. And actually I will unpin the viewport while we work on our scatter geometry. So let's set this to an open arc. We will set this to ZX plane and we will increase the uniform scale by quite a bit. Let's do something like 50 and we can play around with the arc angles here so we only have this semicircle right in the back. And from here we will do a scatter. Let's maybe decrease the force total count and disable relax iterations. Maybe we need even less points. And with these points we can introduce a little bit of noise with a point jitter. Let's increase the scale quite a bit and let's remove any distortion on the height. So we will set the scales here to 1, 0 and 1. So now I can continue to increase the scale to introduce some noise, and we can play around with the seed as well. So now finally we can go up and we are going to see our instance trees here in the back. And now I can actually pin the viewport and even go through the camera and we should see our trees in the back. So if I step back inside our instancer, as I change the seed, we can see how our trees change here in the back. And we can play around with this circle. We can increase the uniform to push them further away from our camera. Maybe we can increase the total scatter here. We can scatter even more trees and even increase the scale of our noise. So just a very quick and easy way to populate this area here with trees in the back. So if we go back to our camera and do a test render, this is what we have, and we obviously have to preview this with our Karma Physical Sky. So this is the current result, and we can also preview some other frames as well. We can go back inside our instancer with our pinned viewport, and maybe I can increase the arc angles of our circle. So maybe I can push this further out. We can kind of see how this changes directly in the render, which is really cool. Let's go back in our camera. We will probably need more trees. Let's do something like 70. And we have to keep in mind that we see how fast and responsive our viewport is, and each of these trees has roughly around 1 million primitives, I would say. So if you time this by 70, we should end up with maybe around 70 million primitives. And since we are referencing this tree file from disk, since it's a USD asset, and also we are using this point instancer, which is super fast and optimized, we can see how fast our performance is in the viewport. And maybe I want to introduce even more noise with this point jitter. Let's set the scale to 100. We can play around with the seed as well and see directly in our render how this changes our composition. We can maybe push these trees back even more, and obviously we are just using here 3 nodes, but you can imagine that if you were to do a more complex setup, you would have a lot more options for how our trees are being placed. Maybe just overall we have too many. I will set the total count here to 40 so we are not blocking so much of this light, and this will be fine. Again, this is just a demonstration. I'm not gonna spend too much time on this part. So from here we can move on, and at this point it's worth adding our Karma fog box and adjusting our sky. So let's go up, and after our Karma physical sky we can drop down a Karma fog box, and let's straight away make this uniform scale a lot bigger. Let's try maybe 100, and we will try to fill in our entire scene, and let's maybe set the density right away to way lower, maybe like 0.01. And if I step outside, we can now adjust our, we can grab the handles of this Karma fog box, and I want to contain all of our trees here in the back to have this nice separation with the depth. And let's make sure that this volume is big enough and we don't need as much coverage here at the bottom. Maybe we can do something like this. So if I go back in the camera, let's also set the scattering phase here. We will bias this more towards our light, which we can see already that we start to get these really cool God rays, and we can also decrease the shadow density quite a bit. And already we can see, and really this Karma fog box combined with the physical sky is such a killer combination. Instantly we can get some really cinematic, super cool looking renders. We can see with just a couple of nodes, and we get all of this nice breakup in our God rays with our leaf geometry, which is really cool. And we can see we almost get this for free, I would say. So really here I'm really just scratching the surface. We can get a lot more advanced with our lights and our volumes, and obviously we can add a lot more elements overall to make this actually more realistic and play around with the composition and everything. So let's for now maybe increase the exposure to a value of 3. And now if I play around with the azimuth, we can control the orientation of our sun. So maybe we can find something like a cooler angle. And again, I don't want to spend too much time because you can really get lost in trying out a lot of these different values. So we can see with just a few clicks here, we completely change the mood of our scene. So maybe finally I'll make this come from the side, something like this. And we can also play around with our fog box settings. We can increase the scattering phase, so we can play around with this, or we can maybe increase the density. But maybe in this case, I don't want to obscure the geometry that much, so I'll leave this at 0.1. We can also give this fog box a tint, so maybe I can make this have a little bit of a blue tint in it if I want, but probably since this is also inheriting the color of our sun, we can just leave this as 0, so we get this natural yellow highlights. We can also just go directly to our sun over here. So in our base, we can just increase the exposure of our sun, which will directly increase the strength of our God rays and our directional light in general. So maybe this is looking a little bit better. Let's maybe use a value of 1. And we can also see we have these very sharp God rays, which is kind of what I want personally, but you can also soften this up if again you increase the size of your light. So for our sun, if I were to increase the angular size, we are going to soften up our rays quite a lot. So we see we lose all of this sharpness, and if I were to set this to 0, we are going to get these super straight rays. And maybe I'll just set this to the default of 0.51. I think this is giving us a cool result. So it's looking good. Of course, we have to preview from all of our angles and see if we like this. Maybe overall this grass is a little bit too green. So from here, there's a lot of adjustments that we can do for each individual asset and material. Maybe I'll change the azimuth slightly. Let's try to get a little bit of these patches of light on our grass. Now again, I don't want to spend too much time here. I'm pretty happy with this. And finally, for our trees, we can add our material variation. So let's not forget about this part. Let's close the render for now and let's go to our stage manager. So because our stage manager contains all of our objects like so each of these are individual objects that we can grab and we can do certain stuff with it. This will be different than our instance trees. So if we go to the instancer here, we only have this instancer object which contains our prototypes with the tree variants. So the material variation node will need different settings for both of these cases. And we can start first with our stage manager. So let's drop a material variation over here. And if we remember from the previous lesson, we will have to select our leaf mesh primitives from all of our hero trees. So we can step inside either of these three assets. Let's grab our leaf geo, place this over here, and replace the first part of this path with a star symbol. So everything that's above our tree group over here will have to be replaced. So from hero trees to environment. Alright, so this will mean that over here I'll get rid of hero trees, trees and environment and replace this with a star symbol. And now we should have access to our hue primvar that we created. And again, we can use snippet over here and we'll do value equals rand, in parentheses we'll do index, and we will place this inside a fit01 expression, and we'll map these to -1 and +0.1 and drop a semicolon at the end to finish the expression. And now if we can just do a test render on this material variation directly, and we should see a different color for each individual instance. And maybe our difference here isn't high enough. Let's maybe try -0.2 and +0.2. So now we kind of start to see a little bit of this variance. We might need to change the seed. So inside this index over here, we can do plus, and let's create a channel here. Let's do CHI and we'll name this one seed. Let's create this channel, and now we have this seed value over here, and if I change this, now we can see our color changes, but it only changes for this single object, and this is because we messed up our path over here. We actually need to get rid of this tree group because this will have a different name per individual components. So we can see tree 2, tree 4, and tree 5, and so forth. So our star symbol really should be before our geo group. And now if we remove the tree from our path, we should have the correct result where all of our trees get updated. And now maybe we can change this back to -0.1 and 0.1. And we can play around with the seed to get a different color, and maybe something like this will be fine. So now we can do the same thing for our instancer, and we can duplicate this material variation, and let's disconnect this. And we can see that the default type for the material variation is set to primitives and native instances, which is what we are working with when we are working with the stage manager. But in the case for instances, we have to set the type here to point instances. And now I can append this after our instancer, and we can plug the path to our instances over here. So I will drop down our bg_trees, which is our instancer object inside the path. And in the case for instances, in order to loop through all of our elements, we will have to do the expression here. Let's open bracket and do star symbol and then close brackets. So this expression with the star symbol between open and close brackets is actually what's going to select all of the instance elements. And if we hover over the instances, we can see in the help card over here how these selections are made. So we can be very specific if we want. If, for example, we want to only select the instances that have an index value that's going from 0 to 10, we can do something like in between brackets, we can do 0 to 10, and it will only select our first 10 instances. So this is pretty cool if you want to be specific, but we want to select all of them, so we will just do a star symbol in between brackets. And now all of our expressions here should still work. So if we go to our material variation, we can see now that we have a different hue for all of our leaf geometry. And let's go back to our final node here from the Karma Fogbox and inside our camera. Let's give this a second and let's move in the camera. So now we have all of this color variation in our leaves, and it will make the scene look a lot more realistic. And so if I were to disable our material variation nodes, let's give this a second, and we can see that all of them are just this overall green, and we can do a snapshot of this. So if I click on this snapshot icon, we can take a snapshot of our scene, and now I can re-enable our material variation nodes. Let's give this a second and let's leave this run for a second, and let's create another snapshot. Now I can double click to go inside this Mplay viewer window over here, and we can compare. We can see that this is with all of the nice material variation and this is without. So pretty cool. And one other thing that we could do here is just add some more attributes on our instance geometry in the back here. So we can probably offset their orientation and rotation. Let's go ahead and inside the instancer, we can go to our point jitter, and we can add a scatter and align node. And again, I want to use the same points that we have. So I will place this in the second input, and let's set this to add attributes to existing point clouds. And we will have to specify a normal for our points if we want to use this mode. So let's drop down an attribute wrangle and just set our n value. Let's do equals set, and we'll do 0, 1, and 0. So we have a normal that points just straight up. So now in our scatter and align, we can maybe change the tilt a little bit, so we can increase this max random cone angle. Let's also give this rotation around normal a max angle here, so they are rotated along the normal. And we can also increase the uniform scale slightly, and let's play around with the minimum and maximum radius. Let's do something like 0.8 and 1.2, and we'll keep this maybe at 1.1. Let's do a render. So just a bit of variation because this is pretty simple to set up, so we might as well do it. Let's also do an output over here, so we are always looking at the correct node. So this is how we can set up the trees, either by hand placing them or using an instancer, and this is how we can randomize their material and all of their geometry variations. So again, with just one single asset on which we spent maybe 10 minutes to build, so we can definitely do something a lot more advanced, but we can see just how far one single asset can take us. And again, if we wanted to, we can come back to our component builder over here and we can make any changes that we want and override our file, and all of the paths and references will be updated in our stage manager and also our instancer as well. And now from here, all we have to do is add our particle simulation. So let's do that with the next lesson. We can now start working on the final element, which will be the particle simulation. Let's go ahead and we can place all of these nodes here inside a network box, and this will be our trees. We'll move this over to the side and maybe make some room, and I'm holding down Shift while dragging to select this node and everything that's above it as well. So I can also make some more room over here. And for our particle simulation, we can just create this at the SOP level. So we can either do a SOP create here and work from within Solaris, but in this case, since we already have our ground geometry at the SOP level, let's head over to this geocontext and we can do our particle simulation here. So I will unpin the viewport, and here is where we have this ball as a reference for where we want our particles. And on this node, if we wanted to bring over geometry from Solaris, so maybe we need a reference for where our trees are positioned. Let's go ahead, let's go back in LOPS, and if we look at our graph, we can see that to bring in our trees, and in this case, let's maybe just bring in our hero trees. I will select this group over here. Let's press Ctrl C, and this will copy this path to our hero trees. We can go back over in Object tab. Let's do another geo container, and we can rename this one to trees ref. Let's step inside and let's do a lop import. And for our lop path, we just have to reference our stage network over here. And if we had another network inside our stage, we would have to reference that network instead here. So for example, if I were to go over to lops, we can drop down a lop network, and if I go inside, this acts sort of like a container, or like how a subnetwork works at the SOP level. So sometimes I use this feature if I want to build another scene within my scene, or if I want to separate the scene. So maybe, for example, this lopnet here can be shot 01, and for shot 02, we could go ahead and maybe copy some nodes over from our shot 01. So maybe we have the same environment, but we change the camera, so we can keep things separate and more organized this way. So if we were to use this lob network, we would have to reference this at the SOP level. So let's go back at the object level. Let's step back inside. So here we can just reference our entire stage, since that's where our primitives exist. And in our primitives here, this is where we actually have to specify our path. So this is where I will copy my hero trees. By default, the purpose here will bring in our proxy geometry. So if I press enter, we can see our trees. And this isn't an animated asset, so we'll set the time sample here to static. And for example, for these trees, we can go ahead and we can bring in the render purpose instead. And this will take a while, but this will give us the render version of our geometry, or rather our hero trees. So if I were to remove the proxy from the list, we now have the high quality mesh of our trees, and this is going to be a packed USD asset. So we can see that we are just working with one packed primitives. Now the trees are rather heavy, so I don't want to unpack this, but for example, if we had to do certain operations on this geometry, we would have to use a USD unpack. And let's maybe just drop this USD unpack just to show you. So we can use the regular unpack USD, or we can use this preset, which will automatically set all the options we need to directly convert this to usable polygons. So we will give this a second, and let's see, we will probably end up with quite a bit of geometry here. So we have around 9 million points, but now, for example, I have access to all of our geometry. Let's maybe go ahead and hide the visualizer for now. I will turn this off. So we can grab grab the geometry now and we can do whatever operations we want. For our purposes, let's say that I just want to bring this as a reference geometry. So I will leave this as a packed USD geometry, and this will give us a pretty good viewport performance. So from here I can just go up and we have our trees from the lobs context, and we can go through the camera and continue to work. So whatever changes we do now inside the lob stage, this will update our lob import as well. And again, we can keep things procedural, which is really great for us. Now let's take care of our particles. We will do a geo container and we can get rid of our ball reference. Let's rename this one to effects. Let's do maybe effects particles, and we'll step inside. We'll generate just a very simple particle simulation. Let's start by dropping down a sphere. I will reset the radius here and maybe increase the uniform scale to a value of 2. And I want to create some leading points that move around in circular manner. So I will drop down a scatter on our sphere. Let's disable relaxed iterations, and maybe we want to have maybe 6 leading points, and we can play around with a global seed to have a nice distribution. So from here we'll drop down a attribute VOP, and I'll rename this one to rotate PTS. If I step inside, we can use a transform matrix to rotate our points around the origin of our scene. So we will use a different method in a bit, but if I were to show you with a transform matrix, let's drop this here. We can use either of the rotate values here, and we can see how our points rotate along each of these axes. Now, if I want to spin around a given axis, it's better if we use, instead of the transform matrix, we use a rotate function. So we can drop this here. So this is how we can rotate a matrix. Now I don't really want to get too much into specific about matrix, but if we were to apply this to our position, so the way we apply a matrix is by using a multiply. We will multiply this with our rotate matrix, and here we can specify the angle which will increase our rotation, and we have this axis over here which we can determine ourselves. So for example, if I set this to 0, 1 and 0, we can imagine a vector at the origin that points straight up with the 0, 1 and 0 coordinate, and our points will spin around that vector. So all we need to do is generate a random vector per individual point. So from our PTNum, we can use this inside a Gaussian random, and we'll set the signature here to 3D vector, and we want to normalize this random vector as well, and we will plug this as our axis vector. So let's plug this inside the axis, and now if I increase the angle, all of our points should spin around this random vector that we created. So all of them will have this random rotation. And now we can simply link the time to our angle. So let's grab the time and just plug this directly as it is inside the angle. And let's check the speed. So I think the default value is actually pretty fine. If we want to have the points move faster, we can just multiply this value, or we can divide it if we want them to move slower. But in this case, I will just leave it as it is. So this will be our random rotation. Now, these are still points, so we need an actual geometry in order to emit particles. Let's drop down a sphere and let's plug this inside a copy to points and use our points from the rotate attribute VOP here as our template points. And now we have actual geometry that we can use, and maybe we can make these a little bit smaller. So this will be our leading points, and from here we can plug this directly inside a pop net. Let's step inside and let's go to our pop source, and scatter onto surfaces will be fine. We can maybe increase the constant birth rate here, and let's make our particles last maybe 2 seconds, and let's see what kind of animation we get. Alright, so pretty good. Let's straight away introduce some movement with just a pop wind, and here I will just increase the amplitude maybe, and we'll do something very simple like this. Maybe increase the swirl size. So we want something very, very basic. Let's also go to our point display here and change this to pixels. Alright, and maybe we can increase the count even more. I want to do, let's do 500,000. Seems to be the right amount. So this is alright. One more thing that we can do here is maybe introduce a little bit of velocity from the movement of our spheres. So let's go up and let's add a trail node on our points. and we will set this to compute velocity. And now we should have our vectors on our points. We can kind of see this very small vector here. So our spheres will inherit this vector, and by default our particle simulation will also inherit this velocity. So we see now that the particles kind of push in the direction of which our spheres are moving. This is all looking pretty good. We can start to introduce some colors. So let's drop down an attribute VOP. Let's rename this one to setCD. We'll dive inside and we can map the color to a normalized age. So let's do a bind and set this to an age, and let's filter this through a ramp and plug this in our CD. So we can go up and we can choose some colors here. Let's set the black one to maybe something like a purplish kind of color. We also want to introduce some white, so let's make sure that whatever colors we are using, we are desaturating them a bit. And for our last color here, we'll go towards like a dark blue, maybe something like this. And in between, we want to add even more color. Let's make this maybe green. So we just want something that's fairly interesting. Maybe do one more point somewhere around here, maybe make this more blue. And for my first point, let's make this even more white so we can kind of see the sort of like the heads of these trails. So not the best result, but this will have to suffice for this demonstration so we can move forward. One more thing that we want to do here is also set the P scale. So let's drop down another attribute VOP. Let's rename this one to set P scale. And again, we will bind this to our NH. So we will do a bind NH. Let's do a ramp after this and set this one to a spline ramp. And let's do a bind export to our P scale. And also I will want a global multiplier, so after the ramp we will drop a multiply and promote the second input here. Let's rename this label to global P scale. And now if I go up, I can go down, reset our ramp, and let's start with maybe a P scale value of 0.1, and we can preview the P scale. If I right click on the texture slot here, we can set this particle display to lit spheres. So now we can see that our particles need to be actually even lower. Let's do something like 0.01. And we will probably want the reverse of this ramp. So let's reverse it and maybe introduce one more handle point towards the end here and set this to a B-spline interpolation. So I just want to fade off the tail end of our trails. And we end up with 1 million points, which should be decent for a simulation. We can probably bump up this value even more, but this will have to do for now. Let's look through our camera and we might have a problem here. Let's set the display back to pixels so we can preview this properly. Alright, so we can actually show all objects, so we see our environment as well, and we can see that we have to append a transform here, and let's increase the translate Y, and we can also play around with the scale. And speaking of scale, after our attribute VOP, so before this transform, let's do another transform and scale our particles up from a uniform scale of 0. So I'll set this to 0. Let's go to the beginning of the timeline, add a keyframe, and we can go maybe to frame 72, and I'll have to leave this to recook. But now we can increase the uniform scale, and actually we should have saved our particles. So let's do a file cache after the popnet. Let's give this a name. Let's do pop trails, and I will save to disk. So now with our first transform, we are going to scale them up, and with our second transform, we are going to move them up. So let's show all objects and let's preview this entire animation. I think this is looking pretty fine. Ideally, I would want the particles to be right on the river, so we can change the river geometry if we want. We have the control of the curve that determines the position of this river, but I'll leave that up to you if you want to do that. Maybe I will just increase my second keyframe scale here a little bit and also bring up the particles even more. So we end up with something like this. One more thing that we can do here is randomize the color slightly per individual trail. And we can do this by applying the same sort of principles we applied when we randomized the color of the materials that we created. So we will need a unique identifier for each of our points. Let's hide other objects. So for each of these leading points that we set up, we will need need to set up an attribute based on their point number. And usually I set this attribute to be ID, but since we are going to create an ID with our PopNet simulation, we can, let's drop down an attribute wrangle and we can name this identifier class. So we will do at class equals at ptnum. So this will be inherited by our spheres and then inherited by our PopNet simulation. And now we will have to recache our simulation. So let's save to disk one more time. And if we look at the simulation, we will have this class attribute. Let's go to the visualizer, and by default this is set to this class point attribute, and we can see a unique value for each individual strand. Let's turn off the visualizer, and in our set cd attribute VOP, let's step inside and we can use a color correct from over here, and we want to change our hue again. So this hue shift, if we change this, we can see how our color changes. So we will want to map a random value for this hue shift based on our class attribute. So let's drop down a bind. We will grab our class and let's set this inside a random, and we can also do a fit range expression, and let's say that we will modify the hue. We can plug this in our shift, and now our shift will go from 0 to 1, so maybe we want to scale this in slightly, and we can do something like negative 0.5 to positive 0.5, or actually I think the first result was pretty cool. We can maybe just alter this from 0 to 6. So I'm pretty happy with this look. And we can see how it all comes together. The same things that we often do at the SOP level, we can now do in Solaris, as long as we know where everything is and how to apply this workflow. Let's go up, let's go back to our transform, and this is what we can bring over into Solaris now. So let's drop down a null, and this will be our out pop simulation, or we can just do out pops, and here we will have like a million attributes from the particle simulation. Again, we want to keep everything clean when we bring it over to Solaris, so let's drop down an attribute delete, and let's delete unselected and only keep our CD, and we will also keep our velocity, so we'll set this to V. And now we should only have these two attributes and our position, so we'll go ahead, we'll copy this node, let's go over into Lops, and here after our trees we can do a SOP import. Let's paste the path here, and we can decide where we want to place this. We don't have to place this inside the environment. We can do another directory here, and we'll name this one effects, and we can do particle sim, and I'll also rename this one. Let's do particle sim, and now we can see we have this effects directory, particle sim, and then inside here we have our points 0. So this is the actual mesh, so to say, of our particle simulation. So it's being brought over similarly to how we set up our grass with just one single object. All of our points are now packed in this one single object as well. So if we do a merge from here, we can bring this over, and we'll give this a second, and here we can see it in our scene. Let's go through our camera. And because we have set up a p-scale attribute already, if we do a test render, or actually we deleted the p-scale attribute. So in our geometry context, let's go back, let's step back inside our effects particles, and here we actually need to keep our p-scale as well. So let's go back over into Lops, and now we also have the p-scale too. So we can probably barely see this over here. We can see this if we zoom in, and typically for magical effects such as this, we need to use an emissive material. So if we go back to our lights lesson, that's where we created our emissive material, and we can also set this geometry to act as a light as well. Let's go ahead and first start with the material. So I will drop down a material library from here. Let's step inside. We'll do a Karma material builder. Let's rename this one to emissive, and I will step inside, and first we want to bring in the color that we inherit from the SOP level, and we can use a USD prim var reader, and normally we would have to set this one to CD, but when the color is being brought over to Solaris, it changes the name to I think it's display color, so it has to be written like this with a capital C as well, and the signature here should be a float tree. So we can plug this inside our emission and inside the emission color, and we can increase, we can set the base color now to 0, and we can go to the emission and set this to a high value. Let's maybe start with a value of 10. So if I go up let's assign this material to our particle geometry. We can also place this, let's get rid of this material path here and place this in our effects and in our particle scene directory. And let's assign to geometry and drag in our points in our geometry path. And if we do a render now, we see our particles rendered with this emissive material. So this can work, and we are going to get nice contributions on our geometry. In fact, we can go back inside our material and we can increase this emission value. Maybe let's try 50. And let's see if we can get overall more bounce lighting information. We can also kind of see this propagated through our volume as well, which is pretty cool. Now we can see we get a fairly noisy result. We would have to increase the samples quite a bit to get this clean result. And what we can do here is treat this geometry as a light mesh. So let's go up and we'll add a geometry render settings. Let's set our primitives paths to our points, and we'll scroll all the way down to our light tab. So here, treat as light source, let's set or create, and let's set this to yes. So now this should clean a lot faster, and let's give this a second when it runs initially. So now this is the result, and we can see that we have overall even more bounce lighting in our scene. So if we look through our camera, this is the result that we have, and I would say that this is looking pretty cool. If we want, we can activate the denoiser in our viewport. So if I press D, we can enable denoising. By default, this will use the NVIDIA optics denoiser, which is pretty good. So I like this maybe some of the time, especially with volumetric effects. So when we are using the Karma Fogbox, it will clean up the volumes very nicely. One other thing that I would like to show you here is that we can also affect the size of our points directly in our viewport. So after our render geometry settings, we can do an attribute wrangle. And when it comes to the p-scale attribute, if we are in Solaris, the p-scale attribute is actually called width. So let's do here at width, and let's do multiply equals, and we'll create a channel here. Let's do p-scale adjust, and let's create this channel, and we have to set the primitive path here to work on our points. And also in the case for points, we have to turn on this option to run on element of array attributes. So now if I adjust my p-scale multiplier here, if for example I set this to 5, our particles will be 5 times as big, as we can see here. And I can set this to a low value like 0.1, and we can see how we can use this method to scale our particles directly inside Solaris. And in this case, maybe I will set this p-scale adjust to 0.5. I think this will give us a good result. So this is how we can bring in the particles, and with the next lesson we'll set up the Karma render settings, and I'll show you how we can set up some AOVs, and also how I did a quick comp in Nuke to further explain these AOVs. We can now take a look at the render settings. So let's drop down below a Karma render settings node. And right away, like I mentioned in earlier lessons, let's point this to the correct camera. Let's also here we can change the resolution, and here I will set this to XPU. And in reality, I would have appended a Karma render settings node way earlier. So usually when I'm building a scene, I will drop down a physical sky and maybe the Karma Fogbox and the Karma render settings node. All of these three nodes, I would usually place them in the scene graph really early on, so that we can build our layout and our effects on top of these already existing settings. So now if I look through our camera, if we have our render settings node, this will now use whatever settings we are choosing over here. So if we wanted to increase the quality, we can increase the path trace samples. We can set this to maybe 256. So now we can see our renders will take longer, but they will have a lot less noise. On that note, if we go over to the advanced tab, in more recent updates, the Karma XPU has some new settings for us that we can choose. Now, generally, I would leave these at the default settings, which they have over here. But for example, we can specify a threshold here for our noise. And we have a few more settings that we can play with, but again, I would just leave them as they are. This will work fine in 99% of cases. So in our main rendering tab, we will have some options for our samples. Now, generally, again, I would leave them at these default settings, but sometimes I might want to play around with the volume step rate. So for example, here, if you have volumes or voxels that overlay on top of each other, maybe you have a scene with multiple explosions and we have some explosions in the back and some in the front. So the voxels will be on top of each other as seen through the camera. You might want to decrease the volume step rate or increase the volume step rate to make the renders go a little bit faster at the expense of accuracy. More helpful will be the limits tab, where we can determine how much quality we want to have per each individual component. So we can see that the reflection limit and the refraction limit is set to 4. So this will mean that our light will be able to bounce 4 times throughout our reflection and refraction. And for example, in this case, since we have refraction from our water, maybe we don't necessarily need 4 bounces, so maybe we can get away with just 2. I will set this to a value of 2, and now we can reset our render. And we can see that for the most part, we get more or less the same effect, but this will now render faster. We can also see that our volume and SSS limit is set to 0. And now because we are actually using subsurface scattering in our tree material, we can bump this up to 1. And now this will mean that we have some bounce lighting in our subsurface as well. And this will overall make our leaves from our trees have a little bit of this global illumination. So maybe I can actually, let's do a test render as it is. Let's go to our snapshot. We'll do a snapshot as it currently is. And let's set this back to 0. And we'll leave this to render for a second. Now the SSS limit will slow down our renders. And this is why the default is set to 0. Let's maybe leave this run for a few more seconds and we'll do another snapshot and let's compare. So this is without the SSS limit and this is with an SSS limit of 1. So we can see that when we have some bounce lighting in our SSS, we have a little bit more brightness overall on our leaves, and especially in the shadowy parts of the leaves, we get a little bit more color again because our light is allowed to bounce on this subsurface scattering material. So as a result, we have a little bit more of a vibrant and luscious kind of look on our leaves, which is probably what we want in the case for vegetation. But again, this SSS limit, if I set this to 1, this will impact our render times quite heavily, so be mindful of this limit. And also the volume limit will work in the same way. If we have emissive material in our scene as we do, we might want to have our light be able to bounce around the volume as well. So let's see in this case if this will make a difference. We might get a little bit more overall contribution from our particle in our God rays with a volume limit of 1. And overall our scene might be a little bit brighter. So if I take another snapshot, let's compare with our volume limit as well. So this is with the volume limit and this is without. We can see right away that we have this brightness bump on our overall scene, and this is because the light is bouncing around in our entire Karma Fogbox volume. So again, this is something that you might want. And for example, let's close this window and we can just disable the Karma Physical Sky, or actually I will set the intensity here to 0. So we don't have any contribution on our light, and we can see the result that we get with just our emissive material on the geometry. And this volume limit set to 1. So this is, I think this is looking really cool. This is a very easy way in which you can do dark scenes if you have some emissive objects. So in this case, because we are rendering this object as a light, we are treating the particles as a light source, we don't really see a big difference if we increase the volume limit here or not. But for example, if I set this to 0 and I turn off this render geometry settings that's turning our particles into light, let's let's go ahead and bypass this node. We can see this is the result that we have. This is more physically accurate to what's happening. We just have contributions on our geometries, so on the diffuse, reflection and refraction components. And now, for example, if I were to increase the volume limit to 1, this will now make our material also propagate throughout our volume. So we can see the difference now. So this is mostly where this volume limit will come into play, where you have emissive objects that aren't treated as lights. So if you want the material to be able to have bounce lighting throughout the volume, you will have to turn this on. So let's set this back to 0, and if we were to treat this again as a light source, this will naturally have the contributions on our volume. So this is generally what you want. And let's go ahead also and set this physical sky back to 1. And finally, we also have a color limit here that is tied. So the color limit is by default tied with the indirect color limit. So this is what you want typically. The color limit is also especially helpful when you have really bright values that go over this value of 10. So if, for example, we have any lights in our scene that have a contribution higher than 10, and in this case we do with our particle material, so our emission strength in our material here, let's go and let's see, we set the emission to 50. So this is the intensity that's being propagated throughout our scene. So if I go up, this intensity of 50 is actually capped at a value of 10, and we might not get the correct colors when we have this color limit. So generally when I have super bright materials, so super bright emissive materials in this case, I would have to bump up the color limit to 50 to match the emission strength that we are using, but we can see that this doesn't really have that much of an effect. We can make a snapshot maybe of this, and let's compare it with a value of 10. This generally is more noticeable with more contrasty scenes maybe. So let's do a snapshot and let's compare. So this is with the color limit of 10 and this is without. We can see with our color limit here set to 50, we might get a little bit more bump out of our volume contribution. So this is what I'm referring to. But more specifically, if we go to our version with a limit of 10, if I were to drop down the color here in our color correct toolbar, we can see this is how our particles get darkened. So we can kind of see this flat color here. We can see that the material is kept at this flat white color, even though here we should be able to see more color if we drop down the overall gain. And if we go now to our version with a limit of 50, we can actually see our color that we are bringing from the sub level. So this is a lot more accurate, and this overall plays a huge part in compositing, because this is usually how I want to render the particles, to have all of this information that I can play around with when it comes to adjusting the gain and colors and stuff like that. So again, this is the difference with the color limit. The problem when we set the color limit here, if we increase this color limit, this sometimes might cause some issues. If you have really bright lights, you might get some really hot pixels, so super bright areas that might flicker around the scene. So this is generally why they set this color limit here to 10. And also by increasing the color limit, you are increasing the render times as well. So be mindful of this color limit. Again, from my experience, I mostly use this because I needed this in compositing. You shouldn't worry that much about this color limit if you are just exporting renders directly from Solaris. Just be mindful that when you are working with super bright materials or lights, you might need to come to this color limit and play around with it. So then we have some camera effects, and here we can enable depth of field, and we can set up some depth of field. Maybe we can go to an earlier frame here. Let's close the snapshot window. We can do a karma edit node, and we can place this wherever we want in our scene. Typically, I like to place this as one of my last nodes. So let's drop down a camera edit and let's point this to our camera. So in our orbit, we'll drop the cam 1 in the primitive path, and with this camera tool active, I can press Shift F and I can select where I want the focus to be directly in the viewport. Let's do Shift Control and fully we should see our focus plane adjusting here. Maybe we can choose another frame. Let's try to focus on our particles, and maybe I can close the scene graph for now. So if I shift click, we can kind of see this area around our particles that is selected, and in our sampling tab we can see that the focus distance is being adjusted as we do our changes. So as I click around, we can see how this changes. We can also, let's set or create, and for the f-stop here, if we have a value of 0, this will disable the depth of field. So we can increase this. Let's start with an f-stop maybe of 2, and let's do a render. So I think we can kind of start to see a little bit of depth of field. Let's maybe go to our Karma render settings, and in the limits, let's go ahead and get rid of our SSS limit, just so we are working with a faster preview. So if I go to an earlier frame, let's go to our camera edit. And here, if I were to reduce the f-stop, we should see a lot more depth of field, and we can kind of start to see this over here. As we decrease the f-stop, we are increasing the depth of field. And maybe while we are working on this, we can turn off the Karma fog box, so we have a faster preview, hopefully. So here we have it. We can exaggerate this. We can set this to a really low value, and now we can see all of this depth of field in our foreground, and also this will be in our background as well, but I'm not sure how noticeable this is in the render. So moving along, we have then in our, let's go to the camera effects, we have the motion blurs. So by default, if we have animated geometry, this will automatically get motion blur from this setting here. But if we had an animation with velocity on the points, we can set this to velocity blur. Now in our case, we have particles, so we will have to go to the instance velocity blur, and we will have to set this one to velocity blur, and this will now use the velocity on our points to generate accurate motion blur. Now our particles are not moving super fast, so this will not affect our render that much, but if we had very fast moving particles, this velocity blur setting will come very heavily into play. So again, I'm not sure how noticeable this is. In our case, we should see a little bit of smearing of our particles. For the instance velocity blur to work, or the regular velocity blur to work, we have to make sure that we have this velocity attribute on our points or geometry. And in the geometry and shading tab, most of these settings will be fine, so we really shouldn't play around with these settings for the most part. But the most important tab here probably is going to be the dicing, which will determine the quality of our displacements. So if we have a geometry with very low subdivisions, we might have to bump up this quality, meaning that our geometry will get subdivided with even more resolution as we increase this. Or if we already have a geometry with enough subdivisions, we can lower this quality scale here, and this will improve our render times, and we could get a similar result with a lower quality scale. So typically here you want to experiment with the values and use the lowest value possible that provides you with the best result. And now we can move over to image output, and here in the first tab is where we can set up the AOVs. By default, we are going to export the beauty, and for most of these AOVs we can split per LPE tag. So if we had multiple lights in our scene, we can give each light an LPE tag, and this will now split our AOVs per individual light. And typically all lights will have this tag option. So if I drop down a light in the Karma tab, we will have this LPE tag over here. So all we would have to do is set or create and give this a tag here. So we can do, maybe this is our rim light. And now if we have this option in our AOVs to split per LPE tag, we would have an AOV with just the rim light contributions. And if we had multiple lights, we would have each contribution split, so we can bring in each individual AOV per individual light contribution. So let's move forward. We have our diffuse, and here again we can choose if we want to export the combined diffuse, and this is typically what I use. We can also have this split per LPE tag. Then we have a lot of options here, but most of these, if you add them together, you get the combined diffuse. If you want individual control over each type of contribution, you might have to export different passes here, but if you want to keep things simple, just export the combined diffuse. In our reflections and refractions, typically I use the combined glossy reflection, and in the lights and emission, again we will use the combined emission, And in the case for our particles, since we are treating these as lights, we will have to turn on this visible lights AOV as well. So we'll see how this works in a minute. For our volumes, we can do combined volume, and in our SSS, again, this is concerning our leaf geometry, we can turn on our SSS as well. Albedo will be just the color, we can check this just so I can show you. And we have the ambient occlusion as well. Let's also check this so we can inspect it. And then in the utility tabs, we can export the world space, we can export the Z depth, so the camera space depth, we can export the UV coordinates, the normals, and really a lot of passes, pretty much all the passes that you might need. And if this isn't enough, you can create your own pass in the extra render vars. If we hit this plus, you can choose the name here and you can see all of the different presets that we have. So really, typically I use this extra render vars to get the Cryptomat IDs. So here we have a preset for the Cryptomat. We can either use material name or object name. I typically like to use material name. So we have a lot of different AOVs that we can export. And if I were to do a render with all of the AOVs that I have selected, we can inspect those. So we can go to this icon over here. And from here, I can select, let's do ambient occlusion. So this is the AO. We have the albedo. Again, this is just exporting the color without any light contribution. This is sometimes helpful if you want to do certain effects. And let's go to our combined diffuse. Then we have combined emission. In this case, we don't have any emissive objects because, again, we are treating them as lights. Our particles will be stored in our visible lights group. And we are also bringing in the sky geometry as well. And we don't want this typically. So we can go to the Karma Physical Sky and uncheck render light geometry. So we are just exporting our particles separately. We can go back to our AOVs and let's look at our glossy reflection. We can also see our particles here, and this is because in our material for the particles, let's go in this emissive materials, I should have set the specular here to 0. So I don't really want any reflection on the particle spheres. So we can get rid of this and let's go back. Let's go to our planes. We have our combined volume. So let's enable our Karma Fogbox back and we can see that here we get all of this nice contribution from our sunlight and also this contribution in the center here from our particles. And I believe we still have the crypto materials. So this is also super useful to do individual grading per element. And then again, we have visible lights and we also have the subsurface scattering pass concerning our leaves. And we also have the depth here. Now, I believe this is different than the depth we are exporting. If we go to our utility, we can turn on this depth camera space, and this is generally what you want. So if we go back to our depth, we can see that we are not really we are getting this really noisy result, and this is because this depth pass will also look at our Karma Fogbox. So when you want to export the depth information, you have to turn off the Karma Fogbox in order to have the correct results. So we can see that as I turn this off, the depth pass is no longer confused with all of the information that we get from this volume that's throughout our entire scene. So this is why typically I do separate renders for the sort of like the main render without the Karma Fogbox, and then one separate render with just the contribution of the Fogbox. So specifically to avoid this kind of situation. So these are some of the AOVs that we can export. Again, we can see that we have a huge list here. So we really have all of the options that we could possibly need. You can even build your own AOVs, so you can determine what kind of contribution from specific lights you want to bring and what component of the render you want to affect. So it's a really powerful system. And now I want to show you in Nuke on the original render that I did how I use or how you can use some of the passes. So this is the render that I exported from Solaris, and we can see that it's a little bit noisy and it's not looking all that amazing. And after we do some treatment in Nuke, we can end up with something like this. Very minimal work. So all we have to do is shuffle out all of our AOVs. So here we bring in the combined diffuse. With another shuffle, we can bring in the glossy reflection. Then we have the glossy transmission. Then we have our SSS. We have our combined volume. And then we have our visible lights. So when we add all of these together, we should get the result of our main render. And I will disable all of the nodes that we applied for all of these AOVs just to show you the result if we were to just merge the layers back together. So this is the result as we exported it from Solaris. And if you separate all of the layers and combine them together, you should get the exact same result. So now we can go on each individual AOV and do some specific treatment and color adjusting. So here I will re-enable all of the adjusting that I did, and we can see that I'm running a denoise on all of these AOVs. Let's go ahead and turn back on all of these nodes. So really we can do a lot of stuff and have a lot of control. So I'm just going to enable all of them. So for example, now if I want a little bit less contribution from the reflection, let's look at our result from over here. I can go to this grade node and I can turn down the reflections, and we can see how easily we can adjust all of these settings. So I'm using this pass for the glossy transmission. I'm doing a grade adjustment to crank up the contrast. I'm doing a blur, and we can add this over our comp, and we have this very soft glow on our grass to sort of help our god rays have a little bit more contribution. So really simple stuff like this is really easy to create in Nuke. Let's move forward. So we add our SSS, and here again, if I want, I can play around with the contributions and we can add everything together. So for our volume pass, for example, I think I graded this, I made this a little bit more yellow, and I added a radial mask to gain down this area in the center where our particles will be. So this is to make our particles pop out a little bit more. And with a blurred version, I'm adding this on top to sort of get a little bit more glow from our combined volume. And this we can see in the shadowy parts of our trees, how this affected. Maybe over here we just get a little bit more kick out of our combined volume, and then we finally merge our particles on top, and we can add glow now just using our particle layer. So I have two separate streams here for the glow of our particles, one bigger and softer one, and one with just a regular glow. So we can add these on top, we can do some final grading, and we can add some grain, and very easily with just a few modifications we can go from this to this. So pretty much no matter what I'm doing, I'm always processing my renders through Nuke. And you can imagine if we were to export more AOVs, more utility passes that we can bring into Nuke to help us grade everything. So we could use maybe the depth AOV to make the background of this composition darker. And we can even use the normal pass to add some additional textures on top of our objects. So there's really a lot of things that you can do in Nuke, and I will highly recommend that you use it as much as possible in your workflow as well. With that being said, this will be the end of this lesson and the end of the course. Now, really with this entire course, I'm just scratching the surface of what's possible in Solaris, but I hope now you have an idea on how to get started using it. This will conclude the Intro to Solaris course. We've spent the last 4.5 hours learning Solaris, and probably we just uncovered about 10% of it. The reality is that this one single course will not make you a master in Solaris, but I really hope that now at least you can feel a little bit more comfortable with it, and that you can use these lessons as a solid foundation on which you can keep improving. If you are interested in Solaris or Houdini in general, check out my workshops and courses on voxite.com. But for now, this is it for Intro to Solaris. Thank you so much for watching, and hopefully we will see each other again in a new course.